In this video, we'll build our AI data engineering pipeline for food delivery application. We'll extract our data and dump it onto Amazon S3. Then we'll use the medallion architecture to load our data onto Snowflake, use dbt to orchestrate our entire transformation pipeline. Then we will integrate AI into our pipeline. In the first segment, we will build a feedback sentiment analysis tool so that we can understand what type of feedback our users are giving. In the second segment, we will build a RAG based chatbot so we can directly chat with our data and find insight. In the third segment, we will build a model to convert text into SQL. So you can just write a simple questions and it will automatically get you the answer. At the end, we'll orchestrate our entire pipeline using Apache Airflow so that it runs automatically. So this video is fully value packed. You will learn so many different things. So without wasting time, let's get started. Hey guys, welcome back to the video. It's been long. I've created an end-to-end project video. So I wanted to create this project from very long about AI data engineering pipeline. Uh, because AI is taking over most of our job and helping us to improve the productivity. I wanted to include some of the use cases how AI helps in the entire pipeline creation. So in this video, we will build entire data engineering pipeline. So we will understand about DBT, Snowflake, and all of the other things. But on top of that, we'll also take one more step further. How we can use our entire data that is coming from the pipeline to build some LLM models around it. When I say LLM models, that doesn't mean that we are building a complete model from the scratch. We will use the existing models and the APIs to integrate with our data set so that we can answer some of the questions. And as we move forward, you understand the entire thing. But this is just a basic. So let's get started and try to execute this video. Again, this video is going to be very long. So sit tight, relax. We'll go one by one about each and every single thing. Even if you haven't done anything around data engineering, I'll try to explain you in a simple way so that you have some understanding. I will highly appreciate if you like this video and comment something so that this video appears to more and more people and my channel is also visible to more and more people around the world. So let's just start with our project video. So Zomato AI data engineering project, right? So we will go from raw CSV data to AI powered warehouse, like complete modern data stack built on top of the food delivery data set that we have. We will use tools like Amazon S3, Snowflake, dbt, Airflow, Docker, OpenAI APIs, and Streamlit. All of the modern data tools will be building. We'll also understand about the batch pipeline, medallion architecture, LLM enrichment, RAG, and text-to-SQL. So, lot of things to cover in this video, and we will go one by one, understanding everything. Now, before we start, there are some prerequisites required, right? You need to know basics of SQL, right? How to write a basic SQL query. It is very important that you understand this. If you don't understand SQL, you won't understand what we are doing around the DBT. I will still explain you some part of it, but I assume that you know basics of SQL and how to read and write basic Python function. If you know this, then you can execute this entire project. If you don't know this, it will be good to have that at least you clear your basics first. And again, if you want to master Python and SQL, check out Data Vidya. Right? So let's move forward. And there are some other things like we'll be explaining like OpenAI API and DBT Airflow. So I'll explain you as we move forward. So let's just start by project and understanding the architecture before we do the hands-on practice. So Zomato, right? If you are in India, you already know what Zomato is. If you are outside, these are some of the similar apps such as Uber Eats, Grubhub, and DoorDash. Basically, it's a food delivery application. You go online, you can order something. So let me just show you a quick demo so that we understand what the business problem is. Because most of the time, when we are building something, it is really important that you know what the business is so that you can answer right questions at the end. So this is an application of Zomato, right? I can literally order, like if I want to order pizza, burger, whatever, like all of the restaurants are available here, all of the food available here, something like this. I can order anything that I want and it will be delivered to my house in half an hour to 1 hour depending on the restaurant location. So this is what the core of Zomato, and you can think of this project as a Uber Eats, Grubhub, whatever you want, because the data set that we'll be using is around the food delivery app. Okay, it's not just Zomato, it's a complete food delivery app data that we'll be using. Now here's the thing, right? We have a client. I will just assume that we are working in any company and we have a client and he comes to us and he has like a lot of requirements that he has this data available around the food delivery of Zomato and he wants to build the entire pipeline. But here's the catch. Now, due to the demand of AI and the hype around the AI, he's also saying that I want AI data pipeline. And he explains all of the concept around us, like, okay, I want this in AI data pipeline, I should be able to write text to SQL and a lot of different things. We go through all of the requirement one by one by one, and then we present this final architecture after a lot of back and forth. Again, we can't stimulate the entire part here, but just try to imagine that we are sitting in a company, we had like 5 to 10 meeting with this client, and after a lot of back and forth, we decided this is the architecture that we want to go with. Now let's just try to understand this architectures in a little bit detailed way, because as we execute the project, you will have the clarity at every point what we are trying to do. Okay, so Zomato end-to-end flow, here we are going to use all of the modern data tools. Again, understand this is a learning project, so of course you can use any other tool in between. For example, instead of Snowflake, you can put Redshift, you can put BigQuery. But what I'm trying to do is try to explain you or try to teach you the highest demanded tool in the market, so that you have a more clarity and know what is going around the industry. Okay, so let me just go to this here, so it's quite easier for you to understand. So first thing is, we have the our data set available here, that is our Zomato data set. This data set I took from the Kaggle. After that, I used AI around to stimulate the data set as per our requirement. Like, I try to add some dummy data that looks like a real data of the real user. I'll explain you as we move forward, but this is the data we have. Like, we have like 7 data available, such as country, user, restaurant, order, and everything. We'll understand the data model of that. After that, once we have our data, like the first step in data engineering pipeline, we have to ingest this data to some kind of location. If it is coming from like API, sensors, DBMS, or whatever it is, right? It comes and we dump this data to some location. So in this case, we'll just put this data onto the Amazon S3. Simple. We don't want to make it a complicated pipeline, because we want to focus on the AI side of things more. So this pipeline, we will build a simple data engineering pipeline using the medallion architecture, and then we'll focus more on the AI side of the data engineering. Then once this is done, we will use the medallion architecture, which is our bronze, silver, and gold layer. If you don't know about it, totally fine, I'll explain you in the project itself. But basically, we divide our storage of the data into 3 layers, so that it is quite easy to manage it. So the bronze layer, we will just keep the raw data as it is, store it as a, whatever data that we get, we store this onto the Snowflake as it is. After that, we will do some cleanup, type, joins, all of the other things, and put this onto the staging bucket. And then we will build our data marts to, gain some final insights from the data. And at the end, we build a dashboard around it. We will try to answer some of the questions, like what is the rest, which are the highest order food, and all of the other things we'll try to answer using this. So this is our simple data pipeline that first we will do. Simplest one, nothing complicated here. This is the simplest pipeline that we will do, and this is the first part of the video that we'll spend most of the time with. After this, we have to basically orchestrate the entire thing. So this is the second part, that once we build our pipeline, we can automate the entire execution of this part using Apache Airflow. It is an orchestration tool. Again, if you don't know about this, we will try to learn it little bit in detail while we execute the project. So nothing to worry, I'll explain you everything from the start to end. So don't take pressure that, okay, I don't know Snowflake, I don't know DBT or whatever. Relax, I explain you every single thing. And then we have this AI layer at the end. Okay, let me just highlight this also. This is our AI layer available. So this AI layer, we will do 3 things using AI. One is LLM enrichment. Here we will try to understand the sentiment of our reviews. So a lot of people put reviews online about the restaurant or about the food. We'll try to understand, are these reviews positive or negative, and try to understand how many positive and negative reviews did we get. Second is the RAG. RAG is a retrieval augmented generation. Basically, you can ask questions around your data, like you can talk to a chatbot. And then we have a text to SQL. So as per our data set, right, we will write, give me the top restaurant from the last month, and it will fetch the entire record. So we'll try to build these 3 things using AI. Again, if you haven't done anything around AI, don't worry, I'll try to explain you everything in a simple way. So I'll keep giving you this assurance while we're executing, because lot of people, right, this is a challenge that I also faced when I was learning, that people just start executing different things and explain things in a, like, top level, and don't try to explain it in a detailed way. So even if you haven't done anything around this, don't worry, we will learn as we move forward, so relax. Okay, so architecture, we understood what is going to be happening, right? We will have a data, we'll upload this data, then Snowflake, then dbt will come, then the Streamlit will come, then below that Apache Airflow will come, and then there are some AI stuff that we will do at the end. So this is the core architecture that we want to execute. Let's move forward and just try to understand our data, like what do we have in our data. So this is the data set that we have available, like the food delivery business. It has a different things. It has users that has the information about the city, sign up date, like who are the users, the users like us, right? We have the name, age, all of the other things. Then the restaurant, right? On the food delivery app there are restaurants available, like who is selling the, like the restaurant, like we have the social tab, and there are multiple restaurants available. It will have the information about the cuisine, city, ratings, and all of the other things. Then we have the menu items, like what they are actually putting there. Then the different orders, so user orders something from the restaurant, so all of the order will go there. Order items, it will have information about each and every single item, the quantity and different things. And the reviews, like, right, people rate the reviews that we can use to fuel the AI. So we have around 7 CSV file. Let me just show you that, so that we can get started. So let me open this. Let me put this here. Inside my projects, I have this Zomato pipeline. So okay, so inside my project, I have created this Zomato pipeline, and you see all of these are the 7 CSV files we have available. So if you click on the food, you will see we have the food such as aloo tikki burger, which is veg creamy burger, and all of the different food items are available here. Then you have the menu. So menu will have its own ID, the cuisine, price, and all of the other things. These are the CSV file format. We have the order items. This is a big file, so it will take some time to load it. So basically you have like different order item with the order ID, then the restaurant ID, food ID, price, quantity, line amount, all of the things are available. I might have modified something. Then we have the orders, restaurant, reviews, and all of these informations are available. Again, we will explore them as we move forward. On your local PC, it might take time because some of the files are quite large. Let me just try to explain you this data set with the data model that I've created using our website. So this is what the actual data model looks like, and data model is basically the visual representation of our data. So right now we are trying to understand our data using a simple by looking at our data, but if we want to understand how these data are connected, like orders or order item will be connected to the restaurant or the food or something like that, or the payment, whatever it is, right? If we want to have a clear picture, we have to build something called as a data model. I have a masterclass on data model available. You can also check that. I'll put the link in the description if you're interested. But right now, just to execute this project, this is the data model we have available. And let's just try to understand what it is. Like on the center around, we have the orders, and orders is the core of our business, right? Because you have the restaurant, you have the user available, all of the other things. But once the user orders something from the restaurant, this is when the business actually starts functioning, right? Without orders, restaurants will be idle, user will be idle. If you connect them using this food delivery app, then the business starts moving forward, and this is the core function of the order. So we need to track all of these orders. So what do we have, right? We have the order ID, then order timestamp, order date, then it is connected with the user ID, so user will order something. Then it is also connected from the restaurant ID, so user will order from that particular restaurant. Then we have the restaurant city, cuisine, item count based, I think, based on the order items. So each and every order will have number of items. So it is again connected with the restaurant ID and the food ID that is available on top, and the quantity and the line amount. And there are more things such as payment method, currency, amount. These are the different things available to us. We can use all of these to understand the total revenue, which restaurant is earning more revenue, what are the most highest demanded food, using the order and order items table. Then we have the simple food table, which is food ID, item, veg and non-veg, simple. We have the menu also available, like for each and every food, which menu it belongs to, cuisine and price. We have the user table available. It's like stores information about the monthly income, occupation, marital status, gender, age, email ID, password, family size, whatever it is, like to understand what type of users we have. We have the restaurant ID, again, restaurant information such as where this restaurant is located, what this restaurant serve, and ratings and all of the other things. And then we have the reviews, like for each and every restaurant or based on the user, they will give the review from 1 to 5 star, or they'll comment something and we store the review date. So this is the entire data model. Again, the very simple one. In real world you will have more complicated information here, like you might store the weather information for the optimal delivery, or based on the weather I will increase the price of the delivery, and there are a lot of different use cases. But again, this is a sample project, so we don't want to go into the complexity side of it. Once you understand the foundation, it will be quite easier for you to execute the same thing on a larger data set, even if it has billions of rows and hundreds of tables. Once you see the data model, you can start connecting all of the dots together and start building it. So this is the core of it, right? And this is the volume that we are trying to work with. So initially on Kaggle we had a smaller data set. What I did, I used AI to simulate some of the data based on the real world use case, how real world users will function, and try to add more and more information. So around we have 10 million rows into our order. So our order contains 10 million rows data, quite huge. We have 23 million order line items and 300k reviews available onto our entire application. So this is the volume that we are working with. Right now it is stored into my local PC, but once we put it onto the cloud, usually in the real world you will get the data directly from RDBMS or the APIs or some Kafka stream that is coming and putting it onto S3. But that step we will do it manually. You can even write a script for that. But right now this is the order volume, and the next step for us, enough talking, like let's take next step for us is to load this data onto Amazon S3. Now let me just spend time to explain Amazon S3 for people who might not know about it. So this is basically Amazon S3 is an object storage available on AWS, similar to the Google Cloud Storage, or you have Azure Blob Storage if you are coming from that background. But it's basically an object storage where you can load any type of data that you want. You have like unlimited data storage available. You can upload object up to 5 TB each time. Buckets are region specific, so whatever the buckets that you create, you can store multiple objects into that particular bucket and stores as a key and value pair. There are more other features such as you can do the versioning. You can also set up encryptions, lifecycle if you want to move your data from standard bucket to the more cost friendly bucket. And the replication is also available if you want to replicate your data across different regions. There are the different storage classes available, like standard, infrequent, one zone, basically based on your access. For example, sometimes you might not use some of the data for 1 year, you don't want to access it, so you can maybe put it onto the one zone access or the glacier instant, so that anytime you want you can retrieve it, but the storage is cost is also low. So these are the concept. Again, just an overview right now to give. I assume like most of you might already know it. If you don't know it, this is the Amazon S3. If you want to deep dive onto this and in future, right, you can just go to Data Vidya Learn and you will find around the AWS, you will find a detailed guide on Amazon S3. I think this will be the freely available. So if you want to understand how the core of S3 works, for example, how the key and object works, for example, when you store your data, how does it actually store inside the S3? You'll understand from the data engineering side point of view also. But right now, this is the enough knowledge that you need to know. Okay, next step is we want to load our data to Amazon S3, and for that you need AWS account. If you don't have AWS account, you can just create it just by going onto the amazon.com, aws.amazon.com. You can just click on to create new account. You add some of your information such as your email, username, password, and all of the other things. It might ask you for the credit card information initially to verify that you are a legit user, but don't worry, you won't get charged. They will not charge you directly. It is just for verification. Okay, so I already have my AWS available here. Let me see if everything is getting recorded. Yeah, awesome. So I already have my Amazon account front of me. What the first thing we want to do is just go to the S3, click onto the S3, or you can just search on onto this search bar S3, and you will be redirected here. Now, if you have a new account, you might not have all of these types of buckets. This is my production account, so I'm working with that. Right now, my region is Mumbai, so closest to my location. You can also select region to as per the location you are in. So again, regions basically means every region has their own data center available. So based on the region, those data will be stored near to your location, so the latency will be quite low. I think it doesn't matter right now for this use case, but in real world use case, it matters a lot. Okay, so the first thing we want to do is just click onto the create bucket. This is a general purpose bucket. You can also select global namespace or the account regional namespace. What does this mean is that the name of Amazon S3 bucket is initially, like when this feature was not available. Let's say if I create a bucket name as Darshil, this will be unique across the entire AWS universe. But now you can also create account specific, or you can region specific S3 bucket. So you can have like same name of bucket across a different region. But right now we'll just go with the global namespace. I'll give this as YT Zomato pipeline, and now at the end I just do development. uh, if I create this bucket, you won't be able to create the same bucket right now, because this namespace is global, so you can just add your name at the end or something unique with your number or whatever that you want to do. Everything else we want to keep it same, we don't want to touch anything, and just click onto the create bucket. Okay, so our bucket is created, white is Zomato pipeline DL is available to us. Now the next thing is we want to load our data to S3 bucket. That is what our this pipeline is, right? We have the Zomato data available on local storage right now, and we want to load this data onto the Amazon S3. Now this part we can do multiple ways. One of the way is either we write a script for this, we upload the script that will upload all of this data one by one. We can also do it on the terminal. We have been doing, like if you have followed our previous project, we directly write like AWS CP command and put our local data to the S3 also. And the third way is manually uploading it, just like we do it using the UI of the S3. Okay, so in this case, what I'll do, we'll just do it manually for now, right? I don't want to have a complexity over here by writing a scripts and all of the other things. Those things we will do when we work with the, as we want to mainly focus on this aspect and all of this aspect. This part we will keep it simple. We will manually create it so that we have a clarity of how our data is structured. A lot of times when you just do it directly with the script, you might miss that. So this part I want to do it manually, and so that you guys can also feel like you're doing something while executing the project, okay, instead of just watching it. So what do we need to do, right? We need to create S3 bucket into this structure. So let me show you how the structure looks. So this is the structure we'll be following. We have our bucket name. Inside the bucket, we have the raw data, the raw folder available. So again, we are going to divide our data into the raw, staging, and Marts. So we'll have a raw available, and then we will put each and every data into the respective folder. So it works like this. Okay, first click onto the create new folder and give this as raw, and I'll click onto the create folder here. Once the raw folder is created, then I'll go and let me just open my Visual Code. So first one is our food.csv. Okay, so what I'll do, I'll create a new folder inside this and give the name as food. The food is created. The same operation I will have to do it for each and every one of them. So I can just do menu and create a new folder as menu. Then I have order items, so I'll create a new folder for order items. And then we have orders, so I'll just do orders, create new folder. Restaurant, I'll just start restaurant. Let me just give this name as restaurants. Okay, we have like multiple restaurants. Then reviews, so I'll create a new folder as reviews and users. Okay, so users. So all of these folders are created: food, menu, order items, orders, restaurants, reviews, and user. Now we just have to upload them one by one to the respective folder. So let me just open this, and I'll you can directly drag and drop, I think, here, upload it, can upload this. So food is getting uploaded. If I close this, you will see inside the food, I have the food.csv available. Now you have to repeat the same operation for menu, order items one by one. So let me just do it. You can also do it one by one. So I'll track the menu and I upload. Uh, this will take some time. Okay, this is done. And after that, I will go to order items. And I will upload this. This is around a 1 GB file, so it might take some time depending on your internet connection. So let me just wait this. Once this finishes, then I'll again upload all of the other files. But remember this, right? You don't have to do this manually. You can just write a simple AWS CP command to directly create the folder and upload it. That is more efficient. And also write a script, Python script to read the data and upload it. That is also possible. But this is just a simple aspect that I wanted to show so that you understand different process while executing the project. There are multiple options. There is no right and wrong depending on the data site. So if this was a petabytes of data or terabytes of data, we wouldn't be doing this because the data might directly come from the RDBMS to our S3 location. So we don't have to do this step. Or if this data was available on API, then we might have written the Python code to fetch this data from that location and put that data onto the S3. So again, hundreds of ways to do this, but this is the most simplest way right now, directly manually upload the data so that we get the clarity of how our data is actually organized. So we have our raw data available. Inside the raw data, we have all of these folders. So we are done with order items. Let me just upload the orders. After that, I will do for reviews. Reviews is also 25 MB file. And then after the reviews, last one, users is also 11 MB file, so won't take much time. So order items is the only one I think that takes a lot of time. Other than that, all of this is done. So the simple part is done, right? We were able to load our data, upload by using manual upload. So this is done. So let me just put this, what we have completed till now. These two parts, just this is done here. Let's put this. Okay, so these two things are done. Again, pretty simple, nothing complicated as of now. Simple execution of having our data onto the local storage and then uploading this data onto the S3 bucket. We have completed our initial setup. Let's just try to do these three things, which is create a Snowflake account, put our data onto the Snowflake. After that, we'll do the DBT to do the staging and the Marts thing. Okay. So first of all, you need to create a Snowflake account. So all you have to do is just go to the signup.snowflake.com. You just have to quickly fill this form. You can give any name of the company. Right now, I'm just giving Data Vidya. You can give NA or your name itself. It just doesn't matter. Job title, I'm the founder here, but you can put data engineer or whatever your current title is. If you're a student, just put student. Enterprise, we'll just go with the enterprise. We don't need business critical. We'll go with the AWS. Region is Mumbai. So make sure you select the region that you have selected here only, like whatever the region that you have selected. So select the closest region as per that. I have to agree and I get started. And let me just verify this. Verify I'm a human. Select the bus is here. Okay. Let me just skip this, and this is setting up my account. Once the account setup is done, you will get an email on your registered email account. So let me just open that. So I got this email. I just have to click here, click on to activate. I'll just give the username as data with your support. You can give your name, and I'll just use some password here. Let me think. I'll just use the strong password for now and use a strong password. Let me just copy this and paste it onto some document. So I'll just create this new document for here, credits. Okay, again, you do not have to share this credits to everyone. Right now I'm doing it, but after a point I will delete this account. So just for the tutorial purposes, I'm showing this, so showing you this entire thing. So I'll just put the information here as password, Snowflake password here right now, so that I can directly copy it in future when we need it. Username is this, username is this. and just I create this. Once this is done, my Snowflake account is created. You'll see you have around $400 credit available. So you can use this up to 30 days to build this project. So you won't get charged anything while we execute this entire project. Okay. So again, our Snowflake account is set up. Now what we need to do, we need to start preparing our entire account so that we can load this raw data that we have available onto Snowflake. This is the part that we want to do. Like the first thing, we want to load the raw data as it is onto Snowflake bucket, and for that we need to prepare some of the scripts. So again, if you haven't seen the Snowflake UI, this is pretty simple, right? All of these companies try to make the UI simpler. Gone are those days like people used to build a complex stuff so that you have to, configure cluster and all sorts of things. Now everything is abstract, so you just have to see some buttons, you have to click the buttons, make use of it, and you're done. Let me explain you this UI a little bit way. So if you are seeing it for the first time, you get the clarity of it. But again, they keep changing the UI in future. So if you are watching this video in the future and if you see the different UI, don't panic. They just keep changing just places around there, but the core functionality will always be the same. So you have the projects where you will see all of your workspaces available, such as the files that you put and everything is available. So you can create and manage everything at one place. Then the ingestions, if you want to add data, copy history, migrate some of the data from these other data sources, you can easily do that. Then you have the transformation available. You can write some of the transformation job and schedule it. AI machine learning, if you want to do some of the machine learning uh, about the agents and the uh, ML work, you can do it. You want to monitor everything that is going on your data, the queries that you run, you can also do that. Some of the applications are also available in marketplace. If you want to connect to it, you can also do it. Then we have the like main catalog. So all of the databases that you have right now, these are the sample databases we have available, but we will create our own database as Zomato. So it will be available here. If you want to share your data, you can share it. Governance and security, every single thing is available. There's a compute available. So when you write your query, it will execute, it will be executed on to this compute. So if I go to warehouse, and if I create my own compute, I can easily do it here. This is a free trial. We have 400 credits available. So if you want to start a larger warehouse, you can also do that. But right now, this is all we need, the standard compute warehouse, good for our use case. Then you can also create a Postgres instance and all of the other things. Again, not that complicated. All we just need to do is just follow instructions and you will be able to do it. Now this part, first of all, what we will do, we will create our first setup file. So let me go to projects, go to add new, click onto the SQL file and give as 01 underscore setup.sql. Let me zoom this so that you guys can also see this, okay, how this looks. Let me close the home. So this is where I can start writing my queries, and I can also use AI, but this is where I can just start writing my query to execute. Now I have written some of the SQL query so that we don't have to do the basic stuff. So let me just copy this query and I'll explain you one by one. Okay. So this is the query, and this query is available onto our GitHub repository. So you can go one by one and try to write it by yourself, or you can just paste it. First is we use the role. Again, every time you work with the database, you have to assign a role that has a specific permission. So we'll use the account admin as a role. So if you select this, if you run this, right now, let's say it is already in the account admin. For example, let me change this to the public role. And after that, if I run this, it will automatically update to account admin. Okay. Then we'll create a new warehouse for ourselves, which is basically Zomato warehouse. Create warehouse if not exist Zomato warehouse. Warehouse size is small. Auto suspend at 60. You can also do it on UI, or you can just write a query about it. So execute this. This will create a warehouse, and you can also go and check onto the compute, and you will see. Let's just wait for some second. Yeah, the new Zomato warehouse is being created, and once you start executing the query, it will also start. Okay. Let me just go back to the previous SQL setup. Then we will do some of the database and schema, we want to set up the entire thing. So this is our setup. So first we will create our database as Zomato. After that we will create a different schema. So we will load our raw data into this staging data. After we clean some of the data over here, then the final gold layer, which is a Mart data snapshot, and the AI part will be stored here. So these are the different schema that we want to store. So let me just select this and execute. As we start adding our data, this will go to the particular schema that we have. So we have raw, staging, marts, which is our bronze, silver, and gold, and the snapshots. When we use TPT, we will put that, and the AI pipeline, right? Whatever the AI tables that we create using OpenAI, the enrichment of LLM, the sentiment analysis, or all the things that we do, we will put it onto the AI schema. And after this, we just have to grant some of the permissions. For example, we create a DBT role. So when we work with the DBT, the permission to execute a query onto this warehouse for both DBT and access data and all of the other things will be given. So let me just run this query. So DBT will have all of the access when we are working from the local. So this will basically give the usage, operate all the database access, all the schema, future tables, future views to of the Zomato database to the role DBT. So when we connect our DBT to the Snowflake, this will have all of the required access so that we don't run into the permission issue. And then you can just see these information if the everything was successful or not, and the setup is uh, s- successful. So this is the initial setup that we wanted to do so that we don't run onto the same issue again and again. Now again, when you are working in real world, you might not need to set up everything at one point. You might first just create a database for a simple Zomato, then you start adding schema one by one, and then you create a role and do it in the future when you're working with a DBT. I just wanted to set up it right now so that we have the clarity that everything is set up, so that when we are doing a writing code and executing different things, we don't run into the same problem. Okay, so setup is done. Now this part, which is a core part that we want to work on, the connection between Amazon S3 and the Snowflake, so that we can load our data. So for that, we have something called as a storage integration that is available on Snowflake. So we'll create a new, again, SQL file. We'll give 02 storage underscore integration. Let me see if you guys are able to see it properly. Yes, you can see it. Awesome. So storage integration, and here we want to integrate this let me just close this. Yeah, we want to integrate this Amazon or your AWS account with the Snowflake. So we want to connect them, and for them, for that particular thing, we have something called a storage integration. So let me just show you the storage integration quickly, what it is. So when you want to connect your Snowflake account with Amazon, there are two different ways. One is you can directly provide AWS access key and the secret key and create a stage around it. Basically, you provide all of the credentials inside the script only, and you directly connect it. But that is not the secure way, because your credentials can be leaked because it is inside the script. The second way is what we call as a storage integration. So this is a more secure way. It is a Snowflake object that stores the connection details for accessing an external cloud storage like S3, GCS, or Azure Blob, instead of embedding credential into every stage. So if you see about the stage data loading, right, in the stage, what we do, we try to put the credentials here, which is like AWS access key and the secret key, and you create an external stage, and then you connect with the S3 bucket. But if you use something called as a storage integration, you don't have to expose your entire credentials. All you have to do is just put the connection string, and you will be able to create a connection between S3 and Snowflake. Because right now, Snowflake is somewhere else, S3 account is somewhere else, like your AWS account is somewhere else. There is no direct connection. We have to connect them together. That is the first step. And to connect, either you can create a stage where you have to put the credentials, or you can create a storage integration. You can read more about this if you want to go in detail. If there's also document available, like if you just search storage integration Snowflake, and you will get a complete understanding how to create a storage integration, what are the different things are available. Everything is available here also, so you can always explore the more part of it, but this is the quick understanding that for this project to execute. So the first thing, we'll again do the use role. We have account admin, and then we'll do create or replace storage integration. Okay, let me zoom this so that this is also visible. Now we will give the name as Zomato S3 integration. We will have type is equal to external external underscore stage, then storage provider is equal to S3, okay, into the symbol single quote, and then enabled 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 is equal to true. Then we have to put storage AWS role ARN is equal to, right now we'll just put role ARN dummy, and then storage underscore allowed locations, and the S3 bucket that it is allowed to take data from, so which is like S3 comma and whatever the bucket name that we put in future. Right now we will modify it afterwards. So this is like that, and again this has to be in the single comma quote, single quote. So this is a simple syntax. If you go, let me see if this is available. Yes. If you see, you have like create or replace storage integration if not exist, then you put the name, then you give the type as external stage or the Postgres external or whatever it is, then enable true or false, then you give the allowed location, whatever the location that you want to block, and you can also put the comments here also, okay, and you can also put the comments here. And if you want to read about the each and every parameter, like what are the external stage and what is the true and false means, and allowed location, what each and everything means, you can also go through the documentation to understand. You can also go to the data with this will give you more visual understanding to understand the same concept. So this is the first query that we have. So now we have the simple dummy syntax to create the integration. Now to actually create the integration, we need to get these two value, which is the role ARN and the S3 bucket. S3 bucket we already have. We have to get this role ARN, and for that you have to go to your AWS and just write IAM, copy, and open the IAM into the new tab. Here we have to create two things. One is policy that has the access to just S3 bucket, and second we have to create a role. So policies are basically you create a different policies to grant specific access. You'll understand this. Let me just click onto the create policies. I click on the JSON and let me get the policy available. So this is a simple policy available that again you can find it on the GitHub repository. I've already added that. You have the get bucket and get object version. We allow this, and we also allow these things. Now AWS already has a lot of different policy templates, but we want to have a secure access, right? Like there are policies available. Let me just show you this quickly so that you understand what we are trying to do here. So policies are available by like it is created by AWS automatically, and the policies are, for example, admin access, right? This gives access to all of the resources. Star means everything, right? This gives access to all of the resources. For example, if you open, let's say S3 full access, there is a full access available. So this will give action which is S3 all of the access to S3 buckets that is available in the account to do like list the object, delete the object, everything will be given. There is also Amazon S3 read only. That basically means this will give access to get and list, which is allowed, and describe some of the things around the EC2. But other than that, if someone wants to delete something or add something, it is not allowed. So these are the different policies that is being created for us to directly use it. So right now what we are doing, we are creating our own custom policy for our project, because there is a rule onto AWS or any cloud platform, least privilege access. Okay, least privilege access, let me explain you. Least privilege access, that says that a principle of the least privilege basically is a security best practice, that you only give access to the things that is needed. You don't try to give access to everything. Now for this project we could have given access to all the S3 bucket or just read only or something like that. But again, all of these things we have done in our past projects. If you have followed me from long time, that we directly give admin access or S3 full access. But now we want to focus also on the security side, that we only give access to the things that is needed. So you can also do it on the visually if you want. You can just select the different actions we have available. But JSON is the easiest way. You can also ask AI to do that and it will give you the complete JSON. All you have to do is just update your bucket name here. So our bucket name is Zomato pipeline DL. I'll put it here. Okay, and let me just put it here also. So this is how your policy should look like, right? There are no syntax error. Make sure your bucket name is added, everything is added. So what we are giving access to get object and object version, list bucket, basically a read only access as of now. So I'll click on to next. You can give this policy name as Zomato S3 read. You can give the same as it is. It is not global. And our Zomato S3 is created that has limited access to the S3 onto specific bucket only, not all of the buckets. So our policy is created. Now we have to create a role on AWS, right? We have like multiple things. We have the user. So these are the actual user who can log into AWS console. Then there are roles. So again, to understand this simple way, roles are the way services talk to each other. For example, I want to give access to S3 bucket. I want to give access to Snowflake to read data from S3 bucket. One way is I can create I am user, give the credentials, which are my access key, secret key. Not a secure way to do that. So I'll give the access to them and then it will be able to access the entire thing. Another way is using role. So it gives the assume access, like all of the credentials will be behind the AWS itself. No, nothing will be exposed. All you have to provide is the role name or the ARN, which is what we want to put here itself, which is a role ARN, and that will have an access available to it. This is a crucial step because this is how these two things connect. So all you have to do is click onto the create role. Now click onto the custom policy, right? What we are doing is the creating a trust policy between AWS and Snowflake. Here we have this policy available. Between we have to paste this, which is AWS ARN account ID and the root. We just put the space here. All you have to do is just put this over here and we will replace this afterwards. Right now we don't want to touch this, but I'll click next and then I'll search about the role that we created, which is Zomato. If you just search Zomato, I'll click this role. I'll give the access and this is our Snowflake S3 role. And I'll click onto the create role. I think this already exists. So let me just give YT Snowflake, YT Snowflake S3 role. Okay, and I'll click onto the create role. Account ID. I think we'll have to add a temporary account ID for now. So what we'll do, we'll just put this your profile account ID. So if you click on the top right, click copy the account ID and paste it here for now, and click on to next. We have Zomato available. We click on to the next. This is same and we click on to create one. We will update that role because we will have to put the Snowflake account ID. But right now what we just did is just Snowflake. If you see the YT Snowflake S3 role, it is created with these permission. Okay, and the trust relationship right now is this, but we will update this afterwards. What we need to do is we need to copy the ARN of this because we want to put it onto the integration part. So I'll copy this and I'll paste it over here. So my ARN is available. Is this? Yeah, ARN is available. Also, I need to update the bucket name. So let me update the bucket name as per our YT Zomato pipeline, and my bucket name is also updated. Let me try to run this if we get error or not. This is again, our integration is successfully created. So this part is done. We also need to give access to this integration to our DBT role in future because we will automate this with DBT. So this is basically grant usage on integration Zomato S3 int. Okay, to role dbt underscore role And let me just select this and run this. This is done. We have also given the access, and now you have to describe. So describe integration Zomato S3 int. Run this, and let me put this properly so that you can see it. Now here there are multiple things available. So our integration is created, and once you use this command, which is our describe integration, this will give you all of the information related to description. We have to copy two things, right? Remember, we have to copy two things. One is storage AWS IAM user ARN, okay, which is this one. So I will copy this, which is this part. I will copy, and right now I will put it onto our creds, which is Snowflake AWS user ARN. I'll paste it over here, and then storage AWS external ID. I will copy this and I will paste it here. These are the two things we need in order to create a trusted relationship with our S3 or AWS bucket. So again, storage AWS IAM user and the external ID. These are the two things. Do not copy the role one. Right now we don't need it. We need this only. Okay. Now you go to AWS where you created your role and click onto the trusted relationship. Click onto the edit. Here you have to again paste this updated policy. Let me just paste this. Let me update this with this one. Again, this is available onto our GitHub repository, and here we have to update these two things. One is storage AWS IAM user ARN, so I have to copy this from that we copied from Snowflake, and I paste it over here. And then condition of external AWS ID, which is this one that we copied as it is to this one. If you do this step correctly, what it is giving is that one, we created AWS role and created integration with that role. So if you see the role available here, okay, which is our YT Snowflake S3 role. So Snowflake knows that this is the role and this is a permission, but AWS does not know. So the connection should be both ways. So we also give the Snowflake user ARN and the AWS external ID for to be added onto the trusted policy. And once this is added here in the external ID, you update the policy, and now your connection is created. Like again, we have to do this entire thing just to create connection. The simplest way could have been possible is just put the AWS access key and secret key, and we might have finished that in like 1 minute. But just doing this gives you more secure access and a long-term access to access data from our AWS S3 bucket. Now you can just start doing the next thing. So this is done, the first part, which is just the connection part is done. This small thing, small thing, the connection is done. We haven't loaded our data yet. So this we will do right now, that we will load our data to Snowflake. And let's just go, let me just put this below, open this. I'll just add a new, create a SQL file 03 underscore stage under and format.sql. And here we will have to define some of the things before we load our data to Snowflake. So which is use role, again same, account admin, use database. We want to load our data to our Zomato database, and we want to load it onto the raw schema. So use schema as raw. Then now there is a concept called as a file format onto Snowflake. Let me see if we have available here. Okay, yeah, file format is available. So before loading our data to Snowflake, we have to tell Snowflake these are the types of files that is coming while we load our data. So we have to like give different instructions. If it is a CSV file, JSON file, Avro file, ORC file, and we have like set of files always coming. So we explicitly tell Snowflake that okay, these are the information that is coming and this is how you have to manage this. And this is the reason you have to create something called as a create or replace file format that has all of these information available. Like it is delimited by comma or tab. You have to skip the first header because it is the header name. The new line starts with backslash n or something like this, right? It is enclosed by single quote or double quote. All of this information you have to tell Snowflake beforehand you load your data, else Snowflake will do it automatically, right? So sometimes it might do the right thing, sometimes it might not do the right thing. So this is very important. So all you have to do is just write create or replace file format Zomato dot raw dot, you give the file format as CSV format, then type is equal to CSV, compression I'll just give as auto, field delimiter is equal to comma because it is separated by comma, field optionally enclosed by uh, double quote, skip header as 1. If there are empty field as null. So if there are any empty value available, we will consider them as null. Null if there are like again uh, these type of empty values, or it is like backslash n, or if it is null, this should be in the single quote, trim spaces false, and we have error on column count mismatch. If there are messy data and if there are like some error occurs, we want to directly load it right now, then we will handle that onto the transformation layer. So this is a simple uh, uh, information that we created. Let me just run this. If we see if we get any error, again this should be into the single quote. I have the habit of adding everything into the double quote for some reason, but again different platform supports different things. This also should be in the single quote. uh, this also should be in the single quote. If there is anything else, no. Let me just execute this now. This will execute. Fill delimiter, I think there's a typo. File format on Snowflake. Let me just go online. Documentation. What do we have? Like field delimiter and paste this. I think let me execute now. Trim spaces. Is it? I think it's trim. Where do we see? Where do we see? We have trim space, not spaces. So let me get this. I think this should work now. Yeah, so it is working. So our file format is created, like we have created like the definition of what our files will be and how do we handle this. So our file format is created, that is basically the definition of what our file will be. Our storage integration is created, basically we can connect our data with the AWS. Now we have to create a stage. Stage basically means that actually gives us access to the data that we have stored, and a stage basically means this, right? So okay, stage as a name location that provides a way to access files from the Snowflake. They act as a bridge between your external storage and the Snowflake table. There can be internal stage inside the Snowflake or the external stage. So if you have like S3 bucket available, you can create a stage. Now either you can provide a credential or you can provide a storage integration while creating a stage. So in this case, we already have the storage integration available. So it will look something like this: create or replace stage Zomato dot raw dot Zomato raw stage. Then we give our storage integration is equal to Zomato underscore S3 underscore int. URL of our S3 bucket of the raw one folder. So I'll just give S3. Let me just put it into single quote, S3 colon slash slash bucket name and the folder name slash, and then file format is equal to the file format that we created here. Now it makes sense that what we are doing, right? We are creating a stage that is using S3 integration instead of credential for this yeah bucket, and using this file format that we created. I'll execute this, execute it. Now let's see. I will do list at this Zomato raw stage. I'll copy this. This will list all of the things that are connected to this stage that we created. And what do we see? All of the different CSV files that is available onto our S3 bucket with the size and with the last modified. Now we are able to list our data that is stored onto S3 using Snowflake. So our connection works, right? We are able to connect and list data. So if we are able to list the data, we should be also able to load this data onto our table. So now we will actually do this part, which is the loading of our data. So create a new SQL file 04 underscore raw tables.sql, and we'll have to start writing the query. For this, again, we'll have to write a lot of queries and create tables and everything. So I'll just show you one, and then we'll just copy paste the existing one. So the simple thing is use role account admin, the same thing. Use database, we have Zomato. Use schema as raw. After this, we have to create a table. Where do we load the data? We don't have a table available onto the Snowflake, right? If you go to your database and if you explore the Zomato, right now all of these schemas are available, but inside of a raw schema, we don't have a table. We have the stage that we created, we have the file format that we created inside the schema, but we don't have a let me see, yeah, we don't have a this table created inside this. And in order to create a table, we have to write a query such as create or replace table raw dot, let's say we want to create restaurant table. Yeah, we have the restaurant table. Then first is my incremental ID, so I'll just do idx. Or if you have seen our data, what do we have inside the restaurant? First is our like simple ID, this. Then we have the actual ID available: name, city, rating, rating count, cost, cuisine, license number, link, address, and menu, right? So we have the IDX as string. Then we have ID as string. Then we have name. What do we have? Like name as string. Then we have city as string, all of the columns, right? Rating, what do we have? Rating as, like, again, it's like 4.4. There are also dash available, so I think it should also go as a string. Rating is string. You can always cast them. Rating count as string. Let me see, rating count. It's like it is like ID, city, name, city. This is rating count, too few ratings like 50 plus. This is also string available. Surprisingly, this is also string. This is string. I think license number will be, we can put that as an integer. uh if it is like alphanumeric, like it also has a name like Z, A, B, C, whatever it is some garbage data also available in between. So I think the best strategy right now is just to put everything as string and then handle this onto the transformation layer. So we are not changing anything, we are just directly dumping the raw data as it is. We have the rating count, and after that we have what do we have, right? Rating count, we have cost as string because it has like the rupee symbol. Cuisine as string. License number as string. Link This is string and menu. Oh, before menu we have address as string and menu as string. Okay, this is done. Let me just execute this one table. Create replace. I execute this. This session does not have current database call use database. Oh, we did not execute this. Execute this. Now we execute this. So our table restaurant created successfully. If you go and if you refresh this on the left side, you will see tables and restaurants is created. Now this is an empty table. So if you just do select star from this raw dot restaurants, we don't have the data available yet here, so this is an empty just column available. The same operation we'll have to perform for all of the files that we have, and it is pretty simple. We just have to write a create statement. Again, we don't want to write everything one by one, so I already have it prepared. I just wanted to show you for one table. Now you can do it for all of the other here. It is same we are doing like for the users, like food menu, orders, like we use the numbers here somewhere, string, date, all of the things, different things we are doing. And let me just select all of this and execute. So one by one it will start creating the table, and once this is done, so our tables are created, like food menu, orders, all of these information are available here. So table is created. Now the next part is loading our data, right? Again, all of these things we are doing for the loading. uh, let me actually give you the fun fact, right? We can directly load your data by uploading onto the Snowflake rather than doing entire thing. But the point here, right, you can literally go to the Snowflake, create a table and upload the CSV onto directly onto the Snowflake UI. You don't have to do this entire thing, but that is the main part that we are learning here, is how to do this in real world. Because in real world you will not get small CSV files, you will not get like few MB file, you will get terabytes of data that will directly come onto the various storage bucket, not just S3. It will be either be on the BigQuery, it will be on the MS SQL server, somewhere in the legacy server. You might have to connect with some API, maybe write some script, load this data to some location, then put it on the Snowflake. Lot of different things can happen. So that is the part that I'm trying to teach you here, is how do you securely do everything, right? Everything that we have done till now is very securely. The policies that we created, the role that we created, the connection that we created does not expose any connection string right now. So this is the best practice how we are executing this one by one. Now databases are created, we want to load our data, and we have to again create a new SQL file. Again, you can do this into the one entire SQL file, but it just it's quite easier if you just divide it, so that you can keep track of different files, and you can also schedule them to run one by one in future. Like 05 copy into. Now comes the loading part, which we want to load our data, and this will make our life entire easier. So again, the same thing, use role as account admin, colon semicolon, use database, we have Zomato, semicolon, use schema as raw, use warehouse, Zomato warehouse. Now what we will do, there is a copy command available. Let me show you quickly how the copy command looks. Is that copy? Okay, yeah, it is available here in the staging only. So once you create your table, right, you want to load your data, and to load your data you have this like copy into, then you put the table name, the stage name, the file format information, and whatever the file that you want to load. It looks like this. Copy command, copy into this the target table, the stage, which is the stage that we are using where the files actually lives, the stage that is connected, how to parse, like the file format that we already have created, and the which files that you want to load. So we'll write the query by ourselves. So we'll do just copy into, where do I want to load my data? So I want to load my data to the this restaurants table. From where I want to load my data, I have like Zomato raw stage created slash let me just show you where is that storage. Yeah, so Zomato slash, so it you can access the file like the stage name, which is the stage name, slash all of this information, like food, menu, all of these stages are created one by one. All of the stages are created here, so I can just do from here, uh restaurant, not here, not here. I can go to this, so Zomato stage restaurant. I can directly load, and on error, let's say there is an error, I'll just say continue. Let me see if you guys are able to see it. Yeah, you can see it. Yeah, continue. I execute this. I think there's a typo. Continue, execute this. Raw dot restaurants does not exist. Oh, we did not run this first. Let me just run this again, so that we are working into the Zomato database. And then this is loading. Now what it is doing, it is going from S3 bucket and loaded all of the, like, row pass, row loaded, error limit. So there was no error seen in this file. You can actually see everything is loaded properly. If you do select star from row restaurants limit, let's say 10, and execute this now, you will see our data is loaded. All of the data are loaded into the Snowflake for the restaurant. Now we just have to repeat the same command one by one for all of this, right? So let me just paste, and I will just do the same thing one by one. This will load our data, the Zomato food menu, orders items, and the reviews. All of these go one by one. This is done. Now you can just do the sanity check, which is by writing something like this. You select the count from each and every table and just execute and try to see how much data do we have available, right? So for all of these, we are able to see, like, all of these data are actually loaded rather than having a count as 0. So our data loading is finally done, right? This part of data loading is done. The work of Snowflake and AWS account is done. This is what we have achieved. Congratulations if you reached to this section. So if you want, you can take a break right now and then you can continue. So now we will do the actual part of DBT, where we will write script under DBT. We will set up everything and then we will work on the data marts then. So we'll try to execute this entire thing. Again, we'll follow the same process. We'll connect to Snowflake use for DBT, and we'll try to do everything onto a local PC. So let me just get this. For example, onto this, what do you have? Visual Code. Open the new terminal, and if you don't have it, pip, or you can install. Again, you need to know the basics of Python, but you have to install pip 3. In my case, install dbt dash snowflake. Right now I have the requirement already satisfied, but in your case it might start installing. Okay, it is installing few things here, and I have it installed. There are some errors and warning, but I don't think we care about that right now. Okay, let me just zoom this. So we want to init the dbt project so that we can start executing dbt from our local machine and connect to Snowflake, and then start doing different things one by one. So the first thing we want to do here is init our dbt project, and it is pretty simple. You just have to write dbt init Zomato, right? You write this command and this will set up, okay, it's not int, it's in it. It will create the Zomato folder here, and then you will have to provide different information. For example, let me zoom this a bit. So what does it ask, right? It asks that which are the database you would like to use. So you have to add a number, and in our case we have just installed the Snowflake package, so I'll just add 1 and enter. Then it is going. Okay, the account value of the Snowflake, you can get this. Go to the online Snowflake console, click onto the left side your profile section, connect a tool to Snowflake, and you will find all of this information. So you have to copy the account identifier. For now, what we can do, we can put all of this information here also. Account uh, identifier. Okay, so always we can copy this. So I'll copy this and I'll paste it and I'll hit enter. Then dev username. What is the username that we want to give? So we have to copy our Snowflake username, which is this in my case, which is this the same one. So I'll copy this and I'll put it here. Either you can log in with password, key pair, SSO. I'll select password. So I'll add number 1 and my password is, I have already saved it here. So I'll copy the password and I'll paste it here. And you won't see it visible because it is a password. I'll just enter it. Role, we have already created, if you remember, when we started the setup, here we created our DBT role to work with and it has access to everything. So we'll copy and paste the DBT role. A warehouse name, we also created our own warehouse, which was Zomato warehouse. So we'll put it here. Default database to work with, right now, default database we have is Zomato only. So we'll add Zomato. Schema, we want to work here. So default schema I want to work is staging. So I'll just write staging because we already have our data available onto raw. So I want to start loading my data using dbt on staging. And thread, you can add one or more. So I'll just add 8. So this will do start doing this. So basically what we just did, we have configured our dbt to connect with Snowflake, and we have added the required information such as account identifier, username, password, role, warehouse, database schema, and everything. So all of our information is stored there. And now if you want to see also, right, you can let me just close this, put this below. uh, Also put this like this so that it is easily visible. You can click onto dbt and you will see that it created a lot of different things here. Yeah, you will see dbt project YAML that has some initial data available, like initial configuration available. Then you will see the readme if you want to understand different things. Then you have like analysis, macros, models. We'll understand about all of these different things, snapshot. So one by one we'll try to understand and we'll try to build our entire dbt model. That is our this part, which is we want to take our raw data and build and clean our data into the staging, and then we will put that data onto the data marts, which is all using the dbt only. So let's just start doing that one by one. We'll like do a lot of things here. First thing is just let me just clean this example right now. So let me delete this example and move it to trash so that our models are clean. uh, you can click onto this dbt YAML project, and if you want to set up few things initially, we can do that. So here we will have to work on the model. So usually when you create a dbt, when you run a dbt model function, and if you have watched my like what is that video, Netflix end-to-end data engineering, I have the end-to-end project available on that where I explain entire thing about the dbt. We very detailed we went into that. And usually when you create or run the first model, it automatically categorizes that as a view. It does not create a table. So you have to define that settings into the function or the dbt project file, all of the different types of things that you want to do. So what we will do, we will just modify that information right now, and so that we don't get any random information stored. So we will remove this part and you can just write it with me as staging. Okay, the staging, we will keep the materialized as view plus schema goes to staging. Let me put it this here plus, and then I'll put it here. After this we have Marts. Okay, okay, my GitHub Copilot is working. So basically materialize as table. So I want to store all of the staging value as a view. I want to store all of the Marts value as actual table because we'll be querying that a lot. And then I have the snapshot as the same Zomato, and I will do materialize snapshot uh schema. I can put the snapshot. That's pretty much right. So what I just did, I just defined the settings to store my staging and Marts. So whenever we create anything under the staging, or whenever we run the dbt models, this will be stored as a view, because we want to keep changing it. Sometimes we want to update the logic, so we don't want to create the entire table always. We just create a view, and for the Marts we will create it as a table, and all of our snapshot will go into the snapshot schema. So this is how the entire thing will function. Now we want to start working with our model. So here, first we will create a new folder as staging, where all of our staging data will go. And we have to define something called the sources.yaml. This file will have all of the information where our raw data exists, like where do we get our raw data. So this sources file will have all of the information. If you want to quickly understand what sources are, there are two things. One is seed and second is sources. Seed file is basically small CSV file that are stored on your local PC, and if you want to upload it using dbt onto, let's say, Snowflake, you can do that. So these are the small files that are on your PC. But we have also sources. It's basically raw table loaded by the upstream. Dbt just points to it. So right now we have our data available onto the raw schema, and we want dbt to use that schema. So we have to define the structure of where our initial sources are. So inside the staging we define where our data is coming. So it is something like sources, then you give name as raw, uh, database is Zomato, then we have schema as raw. Then we define different tables that we have, such as name is restaurant, you give the description. Then we have name as users. Let me do this. I have the GitHub Copilot installed, so that is the reason it is like auto completing it. But you don't have this description is an optional thing, so you don't have to do it. If I remove it, it's just for our things, or for the documentation that we generate at the end. So this description will be part of it. Then we have name as food. Uh, food. Let me add this. Then name as menus. It's not menus, it's menu only in our case. And then we have, what do we have? Orders, order item, and reviews, right? So orders name, orders name, order items, and name as reviews. Now again, you can find this on GitHub repository if you want like the complete thing, but if you want to write it, you don't have to write the description, or you can write the description by yourself. So we first define the sources. There's a colon here. So we first define the sources. And again, if you're working on to the dbt project initially, you might not get it this the colors of the dbt project. For that, what you can do, there are some extension available online. You can just search dbt onto the extension, and I have already installed this dbt formatter, so it automatically formats based on the dbt project. If you want to install, you can also install this, all of these different things for shortcuts and everything. If you want to do it, you can do it. But I have installed this dbt formatter, and VS Code dbt package is available, so it will automatically format all of the code that I write. Now after this, we will write one macro. Macros in dbt are like a simple functions that we have in our Python, so we can always reuse that macro name to do some type of work. And usually in dbt, right, this let me just explain you in simple way. Whenever you like, the default naming convention of dbt is something like this. There is like target underscore schema underscore custom schema. So by default, dbt follows this structure. There's a target schema underscore custom schema naming convention. So whenever we create our Mart models, it will automatically go into something called as staging underscore Marts. So we have to define some naming convention. So if it doesn't have, it goes to the right schema, and the functions look something like this. If it is a staging schema model, it should go into the staging schema only. If it is a Mart schema model, it should go into the Mart schema. You'll understand when we actually do the hands-on practice. So it is looks something like this. You can go here onto the macros, click and create a new file, generate schema name.sql, and here I have to put this function. This function basically it starts at the macro, it ends at a macro, and there's a function name. It takes the two parameters. This is like a simple Python function only. Custom schema name and the node. Okay, so if custom schema name is none, it will just write it as a target.schema. If it has the value, then it will use that custom schema name. So this is the standard process that whenever we want to write our specific model to the custom schema, we can always do that. So this is a function that will be helpful when we start writing our models. So we have defined our core structure of DBT model, and we will start writing our different schema. The first is staging one, and we can create a new file here, stg underscore restaurants.sql. Now the core idea of staging is we want to clean some of our files, and if we look at our, let's say, restaurant data, let me go here, close this, go to data and go to restaurant. So you have your ID available here, then you have the name available here, then you have the city available here, then you have the rating. Some of the rating are like dash dash available here. So what do we want? Like we want to clean all of these information one by one and to understand what are the issues. So what do we want? We want to just fix all of these things in the code itself. So let me just open the STG restaurant, and we can just start doing it in a simple way. So as we saw on our data, we have some of these issues available, and these issues are like there are like dash dash values. So there are this dash dash value available, so we want to convert this as null. Then a lot of times the ratings are like 50 plus, so we want to convert this rating into like normal 50. The rupees, like rupee symbol space then 200, we want to convert this into 200. So these are the some of the issues we already have, and we want to write a query to parse this information. So we can do something like this, which is basically we read ID as a normal restaurant ID, name as a normal restaurant name, then we trim our city into this regular expression and convert this as a city. When we try to decimal, we convert our ratings into a decimal point and keep it as a decimal. Then again try to number using regular expression, convert our rating count into normal number, and same with our cost. Now again these are the regular expression. If you want to see what they mean, check regex. You go online and put, let's say I try to put this regular expression here, and let's see. So you can go to the regex, you just pasted the regex, and this is the value we have from the restaurant, let's say 250. So what will happen, this will match uh, the number. Okay, it will try to look for the numbers around the script. It will try to extract just number out of it. That is the core idea of the regular expression that we just inserted. For example, if you want to test this with the city, for example, I put this regular expression here, and then let's copy some city name from here and paste it. Okay, so what it will do, it will match the previous token one or more times. So it will match this entire token. So for the city, it will try to clean all of the data. If it has something, let's say comma in between, so it will try to fetch one single value out of it rather than getting the entire thing. So it is just trying to clean the city as city. For example, it cleans the city, again joins two city if it is a comma as a single city. The same with the rating, if there is a dash dash available, it will convert it into the null. Same, it will find the number. Same for the cuisine is same, and the license number is same. So these are the basic cleaning that we want to do it here. Now again, I don't want to go deep dive into explaining each and every functions. I just gave you the overview that here it will just try to clean the city and join the city name properly. It will replace this dash dash to the null. Over here it will replace this plus 50 with a simple number, and this rupee 200 with this simple rupee. So all of these information will be cleaned and put into the staging view that we created. So now the staging restaurant is created, and if you want to run this, you can just do something like let me clear this, dbt run dash dash select staging. If I run this, what it will do, it will go no dbt. Okay, I have to go inside the dbt folder, Zomato. Okay, now I'm inside the dbt folder. I will run this dbt run dash dash staging. This is running dbt register adapter, found one model, seven sources. There is an issue, SQL compilation, listing schema in database. Oh, I think I made a mistake here. While I was setting up the database, I added by mistake Zomato warehouse instead of just Zomato. So let me just update that part. And for example, to do that, uh, I'll open the terminal and I'll go to it is available here on this place. So I'll just do nano uh, dbt profile YAML, and over here I can see these are all the other schema. This is my Netflix project, Zomato, right? And over here the warehouse is this. The database is I added Zomato warehouse, as you can see it over here. If you also made the same mistake, all you have to do is just go here. I'll just show you again one more time. So let me just save this, and yes. So all you have to do is just, if you're on Mac, you can just write nano dbt or vi dbt. If you're on Windows, you can just find this file also available. If you don't know how to find this file, just try to Google it or just ask the chat GPT, I want to update my dbt profile.yaml, and you can just open here. All of these are my previous dbt file, but if you want to see, let me see, Zomato one, it is available here. It has all of the information that we added while we were setting up our project. So this is fixed. This is a one error that I made. Let me now try to run the dbt select staging model one more time. So one model found, it completed successfully. That means our model ran successfully. And if I go to my database, if I go to my staging, you will see there is one view created because we set this as one view. And if I want to preview this, I can just preview the view, and you will see now restaurant this on the rating dash dash are null. Okay, the cost is properly number value, the same rating count. Instead of over here, what do we had, right? We had uh 50 plus 20 plus ratings number and all too few ratings or something like that. So we instead like cleaned our data into the proper number. Quizzes are done, this is done. So now we have our proper data available into the cleaner version. So this is what we did for one restaurant. We have to repeat this step, right? We have to repeat the transformation step for all of the model. Now again, I just showed you one thing. I'll just explain you everything else from the top. We don't want to spend time writing each and every staging, or it will take like 6 to 8 hours to complete the entire thing. So I'll just click onto the new one, just do staging underscore users dot sql, and let me just paste this. I think one more thing I forgot to explain you is this one. From whenever we want to read data or the table, we read from the sources that we defined in this sources YAML. So source is raw and the table name, which is a raw sources table name where the ID is not null. So this is how we put between this is how we read from the sources. So our sources is actually Snowflake, and that particular thing we have defined here, like the name, database, schema, everything we have defined here. So from this source, raw source, I want to read restaurant. From this raw source, I want to read user. So this is what we will do here. So this is the user query. So I select user as customer ID, name as customer name. I lowercase the email. I try to convert age into the number. Then gender as it is, marital status, occupation as it is, monthly income as income band, education, convert this family size into the number, source is raw user, where the user ID is not null. Same I will do for the food also. So let me just get the script. New stg underscore food dot yaml. I'll paste it here. Same, not YAML, sorry, SQL. Yeah, select as food name, init cap for veg non-veg, from this where it looks like this, and then same for the menu. Let me copy this. New file stg underscore menu dot sql. Same menu ID. Try to convert RID to restaurant ID, FID, cuisine. This does not need a lot of transformation. Then we have the orders available. So I'll just do stg underscore orders dot sql. Let me paste it. So we have the stg orders. We are just adding them. After that, we have staging underscore order underscore items dot sql. Again, we'll just do the select and get the data from the source. And then we have new stg underscore reviews.sql. So let's just try to write the reviews, because for the reviews, we also want to join our restaurant data and get some of the column from there. So we'll do something like this. Select r dot review underscore id. Then we have r dot order underscore id. This will come from sources review as r. After this, we have inside the review r dot user id. We will keep it as customer id. User id will convert this into number, comma r dot. Let me see reviews one more time. What do we have? Just copy this first as it is and put them. So review id, order id, user id is there. Just GitHub Copilot. Then we have the restaurant id. So let me just put this restaurant id, rating id, comment and review date. This is done. And then what I'll do, I'll just do left join like a simple SQL. And in dbt, we can use something called as a reference function. So if we want to take the output of other model, for example output of the restaurant, right, we want to join the restaurant with the review so that we can get the restaurant city and if we want any other information. So what we can do, we can use this function called as a ref. Then inside this we write stg underscore restaurants as res on restaurant id. This is fine, where r dot restaurant id is equal to res dot restaurant id, where let's say where I'll say r dot comment is not null. I think that's fine. And here I'll just get, let's say, restaurant dot city as restaurant city. That's it. I'll just keep this. Let me just put this as city only. And this is the review. This is the orders. All of our staging data are complete. So only here we were using the output of this staging restaurant uh, into this particular reviews, and this is what makes dbt powerful, because you can use and build an entire dependency graph where first this will run, then this output you can use into another script, and that output you can use into another script, and then it creates the beautiful visualization so that you can actually track how everything is functioning. And we will also look into that, right? So right now all you have to do is just run the same command, dbt run dash dash select staging. I'll execute this, and again it will start running from start to end. Let's see if we have any error. We got error into stg review for something. So all of the model ran, only reviews broke. Failure in stg reviews, unexpected res somewhere here. So res, unexpected res. Staging restaurants are fine. Raw reviews, res city. Okay, we have to add the comma here. There was an issue. Let me just run it one more time. So as you can see, all of our staging model completed successfully. If I go to Snowflake and if I refresh this, you will see all of these information are available. So let me just uh, quickly review these tables. So here we have like Zomato reviews available, and you will see the city is added based on the restaurant. review date, comments, all of the information are available. So our staging is done. Like we were able to clean our data here. We were able to clean our data and now put it onto the staging DBT. So this part is done. Now the next part that comes is actually getting insights from all of these information. Before we move forward, I want to quickly talk about some of the foundation concept that we want to understand. One is the difference between ETL and ELT. So in this project, what we are doing is that we are doing the ELT part. So till now, if you have seen some of the projects previously, we were mainly doing ETL where we extract data, then we transform, and then we load all of these data. But in this project, we actually built the ELT pipeline where we extracted the data, put it onto the S3, and directly loaded that data onto the Snowflake, raw data as it is. And now we are trying to transform this using the DBT. The transformation part we are doing using DBT. Again, there are two ways you can do the data ingestion. One is batch and the streaming. Right now, we are mainly working with the batch and the medallion architecture that we are using, right? So it basically, medallion architecture is just a best practice that you need to follow while you are building your entire data platform. So raw and bronze layer is data is exactly at it is loaded into the lake. You it is untouched, append only, and the schema is raw, right? You do not touch this data. Whatever the data that comes, you have the true copy of data available into the raw bucket or the raw zone. Then you have the staging or the silver, which is basically where you clean or you rename some of the information as per the source table. So this gets stored inside the staging schema and it is clean data. Like you, whatever the raw data that issue it had, we try to fix it into the staging one. This is what we already understood, right? It has like two rupee symbol and the number or dash dash. So we converted that into the null, or the rating, we removed the rating and just added the number. So all of this information you try to clean it in this place. And then you have the final, which is your Mart. So this is a business ready dimension. What do we mean? That the answer that we want to get about the understanding of the data, like how many restaurants we have that is in the profit, what is the most famous restaurant, what is the highest order cuisine, all of these information you can get it onto the gold layer where you actually build the dimension model, like dimension fact things that we will start building now. We understood about the Snowflake. We understood about the loading data onto the S3. Let's quickly understand the basics of DBT using transformation. What DBT is and why everyone uses it. We already know about this. So SQL select based manage tables, right? Earlier, if you want to manage your tables, it was quite difficult because you had to manage hundreds of SQL. For example, let's say that these things we are doing on Snowflake. Let's say there is no DBT and we try to create like hundreds of SQL script. So every time you want to change something, you'll have to go to the manual script, you update that script, and then build your entire pipeline. So that becomes tedious, and this is where DBT comes into the picture to save the entire job. Like you can just write a select statement, it will create the dependency graph based on that, so you will always know what is going onto the pipeline. It uses the best practices from the software engineering, and DBT stores nothing, right? What we are doing is that DBT is connecting to the Snowflake and it executes everything onto the Snowflake. DBT is more of a layer that is just managing, like it's an orchestration. It's an orchestration layer that manages the transformation side of the things. This is a project setup that we already did. We run the dbt init command. All of the information about our project will be stored inside the model snapshot test and dbt YAML file. This is what it looks like. We updated that YAML file as per our need. Two configuration you need, like dbt project YAML, the project where it has the information about the names, folders, and defaults, and profile YAML where we actually define the connection. You already saw that, right? In our profile, we defined the connections of Zomato and we made a mistake around the schema name, I think database name, and we updated that also by going through. So we also saw that. And the debug is just to see if everything is proper or not. Then we have the sources YAML name that we already know, right? We define all of our sources where our data is actually originating from. So that is in our raw schema. So we define all of the raw schema in our case. And again, you can hard code names into the every model, but it's quite easier, right? So let's say you change the name of orders, and if you hard coded order name into like hundreds of scripts, So instead of going through the hundred of scripts, if you define the sources, you just have to change it at one level and it will be updated everywhere. So again, these are the things you can always manage. You can update the schema or whatever you want to do onto the one file level. A model is just select that we already understood, right? You just do the define the sources as select, write the column name, and do the dbt run. It will run the entire thing. So we also understood about the reference function. So if you want to refer output from a different staging file, you can always use that. And the infer and run order, that we will also understand as we move forward. Now dbt has different materialization. The reason I'm just giving you overview right now, because I don't want to go in detail, because if we spend just time learning about dbt, it will become a dbt course. We want to mainly focus on the AI side, the big picture. So all of these things we are doing just to reach there, so that we can easily understand how we arrived. There was one way, just I just could just show you directly data loaded and the AI part, but I wanted to actually make it like entire data engineering AI pipeline, so it makes sense at the end. So these are the different materialization view we have, how model becomes real. And there are three types. One is a view, the default one. So it only stores the query. It does not store the actual data. So in our case of staging, when we did this, all it is doing in the backend, okay, if you see the definition, it is just storing a query. It does not hold the data. In our raw example, these are the tables. If you see that, it actually stores all of the data on the Snowflake. But when you run the view, when you create a view, it does not store the data. It just creates a view. Basically, it just creates a query layer. So whenever you do like preview view, it will run the query in the backend. The query is this definition one. This query will be running in the backend on all of the tables that we have, and then you get the actual uh, file. So let me just show you one more thing. For example, this is the query we wrote in the dbt using the dbt format. Now, if I go and check the same definition here, uh, you will see it will convert this onto the Snowflake version of whatever the function Snowflake supports. So the create or replace view as, then it will do some select, then trim, try to decimal, try to number, all of these functions, it automatically converted into the Snowflake name. All of everything, it got converted into the Snowflake syntax. Over here we wrote the dbt syntax, but when it runs, when you do the dbt run dash dash staging, it automatically orchestrate everything and converts it into the syntax that the warehouse that you're working on. If this was BigQuery, it will convert it into the BigQuery format. So this is what dbt is doing behind the scenes. So this is the difference between views, tables, and increment is basically whenever the new row comes, instead of loading the entire table, you just try to load that new data onto the table. The silver layer we already saw, right? Raw data is all text or whatever it can be. So garbage data, you have to remove it, and you just try to keep the good data into the silver layer. Then we have the dimensional modeling available. Again, the core foundation of dimensional modeling. So when we store our data into our databases like OLTP type databases, we try to store it into the simple data model into the normalized form. Again, these are some of the foundation concept that I expect that you already know, because this is an advanced project. So we already know about the dimensional modeling, right? Dimensional modeling is all about you convert your data into the more analysis form, which is you have a fact table in between, and then you have a dimension tables that you can connect to do the final analytics. So facts are basically events or measure. It can be like basically our fact order table, the amount, the per order, timestamp, all of the information will be stored here. Dimension provide the context about the particular things like the attributes. So restaurant have like city, name, address, whatever it is. Dimension date, or user have gender, age, city, all of the other information. These are the categorical value or the dimensional value. And then we use this star schema format, where you have one center fact table and then there are other dimension table around it. So these are the core concept that I wanted to quickly revise before we start building our gold layer. So let's move forward and start building the gold layer. Let me see. Yeah, this looks fine. So inside our dbt, right click onto the model and create a new folder called as Marts. And in the Marts, Now we will start writing about some of the analytics query. So for example, let's say I want to create a dim mart. So I'll just open and new file, a dim underscore runs.sql. Okay. And I will put something like this, which is basically as it is, the whatever the uh, information from the restaurants we have, because we this is a by default dimension table, so we don't want to make any changes over here. So dim restaurant is done. I'll open and I'll create like dim customer.sql, and here we will do, let me just write this so we can understand this. Like select from referring the stg underscore users as it is, and then we'll start selecting customer underscore id, customer name, email, age, and we'll write like this is the analytics side, so we'll just do like case when age, let's say age is less than, okay, age is less than 25, then we'll give them as Gen Z. When age is less than 40, then millennials, and if age is greater than 55, Gen X, else when age is Gen X, when age is null, then unknown, else boomer will give this as age segment, right? This is a basically dimension table that we are trying to define into the more granular way. Then we have gender, marital status, occupation, income band, education, and family size. So this is one dimensional customer table that we created. Everything is sort of same. We just added the age segment because on our analytics table we should be able to see a different segment of the age. Instead of just number, we can also get this information. Again, these are the decisions you take while you're working in a company, and you try to think what are the information that business teams actually want to see. So do we want to calculate this information on the dashboard side, or do we directly want to create it onto the data warehouse side so that we don't put the load over there? So uh, this was about the customer. The new file, like dim underscore food.sql, and this is going to be pretty simple, or something like this. Then I'll just go forward with the dim date.sql, and this will store all of the information about the date. So it uses this style with this comma as day from table generator, and select day from this. So this is just generating some random date event and putting it over there, and at the end we have fact orders.sql. Let me just name this properly, SQL. And this will, so now we added 4 dimensions. Let me add a fact table, fact orders.sql, and let me just paste this query here. Now a fact table is an incremental table. So in the PPT that we already saw, right, we had like views, tables, and the incremental. Let me just show you one more time how it looks. So we already understood that views and table views are default. The incremental only process the new rows and merge them in. What it actually means is that, for example, we define the config at top and name it as materialize incremental. Define the unique ID as order ID. Incremental strategy is merge. So whenever the new data comes, either it gets updated or inserted, and if there is any schema change, we append a new column. And then these are all of the columns that we have from our staging orders. Is increment, if is a increment, this basically means the current order timestamp, and based on that, if the new data that is coming, if the timestamp is greater than the current timestamp, that means the new data has come or the new update has come. We will just increment that data. So this is what we call as like upsert method, where instead of appending or adding the duplicate rows, we either update the new data or insert the new rows if the data is unique based on the unique order ID. You'll understand when we actually do the hands-on, but right now this is the core concept. Again, if you want to learn all of these things in detail, I have the video about Netflix data pipeline onto my channel. We also teach this on Data Vidya, so you can always check that out. After the fact orders, let me create new fact order items, fct order items dot sql, and I'll paste the similar query, which is same materialize as incremental based on the order item ID. Incremental strategy is merge, and then same all of the columns from the order items and the order table, and based on the order timestamp available, it will increment the new data. So we have defined our fact table, we have defined our dimension table. We also want to create a data mart. Data marts are basically subset of our data warehouse that answers the specific question. For example, in this case, we will create a 3 data marts. One is about mart daily city revenue.sql. For example, it looks something like this. So what do we have, right? We have our dim tables, which are what do we have, customer, date, food, restaurants. So we have customer, date, food, and restaurant tables. These are our dim tables. Then we have 2 fact tables. So let me put the fact tables here. So these are my dim tables. These are my fact tables, and inside the fact tables we have 2 fact tables that stores the information, the transactional value of the data, one for the fact orders and one for the fact order items. So is fct orders and fct order items. And now we have data marts. Data marts are basically subset of our data warehouse. So this is how it looks, right? You have your data warehouse available, and these are the small subset of your data warehouse, which is what we call as a data marts. We want to create a data marts inside the dbt that answers a specific questions, and it is similar. For example, let me get this. So select order date, city, count of orders, count if order is delivered. Then you do wait, yeah, round of then you do round of cancel order, then sum, and round of count if as AOV. So this is all about the city revenue. And how this works is that we select the data from fact orders that has all of the factual information available here. So it has like order ID, order timestamp, order date, all of these information we have available inside the fact table that holds the actual fact value. Now, here we try to make sense out of this data. So we check the count of total orders, count if the order is delivered or not. So we check the delivered count. We check the deliver count. After that, we check the cancel rate, which is basically count of cancel order divided by total count, then gross merchandise value, and then you have the average order value based on like the total delivered sales amount and the division by the is delivered. So it gives you the average order value. So this is what we call as a subset of your data warehouse data mart. Like this, you will create two more data marts, one for the city revenue. Second one will be for mart underscore restaurant underscore performance.sql. This will be around the restaurant performance. So same, you have restaurant, restaurant name, restaurant city, cuisine, count orders, then sum, total revenue, customer rating, average customer rating, and average customer average delivery minutes. The same will do for mart underscore delivery sla.sql, and we will put this query, which is city, hour, count if round of total percentile 50 and percentile 90, where delivered is this and group by 1 2, which is grouped by these two columns, and you'll get the average. So these three marks are created for us. Let me just put it here. So this 1 2, and we have marks available. Marks are this, marks are this, and this one. Let me adjust the size. Okay. Uh, so this entire thing will, let me put this green, the fact table and the dimension table. Okay, so we have the dimension tables available, we have the fact tables available, we have the mart table available. So you can also build a complete visual of this. We'll see that on the DBT documentation how it actually looks, but this is the core of it. Now let me just run this. So we have created all of these, so let me just run this. Let me just clear this, and we'll do dbt run dash dash select marts, and I execute this. Let's see if we get error. If we get error, we'll just try to solve this. For example, mat depends on the was not found. STG orders, order. Right now we have STG. So inside this one error, inside the mart fact orders, this is orders. I think that was an issue. Let me run this. If we have any error around this, same inside the order items, I think it should be staging orders system. In your case, if you just look the GitHub script, you might not face this issue. Fact orders, STG, referring the staging orders only. Staging orders. Think this file, I think I deleted this by mistake or did not save it. Let me just put this again here. Let me run my staging. So by mistake, my order staging order file went missing. Staging. What? Orders. This is staging orders. Yeah, so I want to run staging. Just staging. Let's run the staging. Yeah, the staging is successful. Let me try running Mars one more time. This vendor. So we everything is successful. Pass 9, total 9. If I go to my Snowflake now, and if I refresh this, so you see dim customer is available, fact order items, and this also. So if I do the daily city revenue, I can check now for, let's say, these are different city available around the world. These are just random city. Let's say we check Theni, total orders 2, delivered 2, cancel rate 0, GMV is this, average order value is 215. Just like this, you can check all of these city, and you will understand total revenue. If you click on the charts, let's see, let's try to visualize this. So we have order date, below total order, instead of order, let's say average order value. Oh yeah, so you will see based on a different date, you will get the total average order value, or you can also see the cancel rate. I think that doesn't make sense. Total number of orders, you can also check that. It is updating. Sum of orders, instead of sum, we can do count of orders. It's just count. I think sum makes sense. Or average order value on day-to-day basis. What is the average order numbers? Uh, Delivered orders or order city is fine. Average order value. All of these things you can see it. We will see this in the Streamlit, but right now I just wanted to show. So all of our dim table, fact tables are available here. All of our staging information are available. So staging is available. Marts has all of these information available. So to go to our, we were able to complete this much, right? We did the raw data, we loaded our staging, we did loaded our marts. Now we want to do some testing around DBT. Once the testing is done, we'll just look at the overall snow site, see the quick visualization, and we'll quickly move to Airflow. So what I want to do is, what we can do is define the test. Again, this is core of DBT, so let me just go here. So what we'll do, we'll do the quick testing of our entire data. So to do that, all you have to do is go to same models and go to staging, right click, new file, underscore staging dot yaml. Okay, and here you can write test like this. So a lot of times when we want to put our data onto a data warehouse or into staging, we want to make sure that all of our test cases pass, right? The data should not have null value, data should have value around this or this range only, it should only contain this value. So before you actually pass the data forward, you have to make sure your data passes the actual data quality check. So this is what we do here. So for staging orders, we are checking that order ID should be unique and not null. Customer ID should not be null. Restaurant ID should not be null. For order items, should be unique, not null. Restaurant for same, right? Unique and not null. Simple testing. Same for marts. So here, new file, underscore marts dot yaml, and we'll write this test here. Over here, we are writing that for fact orders, order ID should be unique. For customer ID, it should have a relationship with the dim customer ID, and order status should be deliver, cancel, or refunded. Like we are, this is a referential integrity, and this is like accepted value. So these are the values should be there. If it is not there, then it will fail. And now all you have to do is just open the terminal, and let me clear this. I will write dbt test run. This will do the automatic test of the two tests that we have added, and this will give us the entire report that does our test cases pass successfully or not. Right now, as you can see, all of this passes, so we don't have any issue. Let me just try to see something. Let's say I update this accepted value to something, let's say my name for now. Sure. Okay, this is the only accepted value, and if anything else, this should throw an error just to test if this works or not. So if I run this, so everything should pass, but one should throw an error, and the same thing, right? Accepted value, it is showing an error because we define that it should accept only Darshil, but right now we have the actual value available, which are these, like delivered, cancel. So this is how the testing works. It actually checks your entire test, or what are the data that is available, and if it is if it matches the entire thing, then it will give you the final report. So this is the testing, and at the end, let me just clear this. You can build the entire DBT model something like this: DBT build, and this will run your entire DBT project from start to end. All of your models will run, all of the testing will be running, all of the marks, every single thing will run from start to end to complete the entire pipeline. Once this runs, basically we see everything passes, no error till now. And then at the end, if you do dbt docs generate and dbt docs serve, this will generate the beautiful documentation for us, and it will run it on a small server that you can actually go and start seeing. So this is how the dbt documentation will execute. This is building a catalog. So our entire project catalog, it is writing to one catalog file. It's not server, it's serve. So let me run this again. Building catalog. Okay, so documentation is ready. If you click here, onto database, you will see all of the data are available into Marts, staging, raw. Simple. If you click onto the project raw, these are the raw data. If you click onto the Zomato, you have the macros available, you have the models available, your entire Mart and staging data is available. If you click onto the right side view lineage graph, you will see your entire how this is connected, like which I told you about. I have the raw data available. From these raw data, what the other tables are getting created from, like staging user is getting created from raw user, food is getting created from the raw one, this staging restaurant is getting created from all of this. So we basically clean this data at this stage. There's a raw review, and then we join this multiple. For fact orders, we have joined these two tables. For as you can see, staging order goes to fact orders and the fact order items. Fact order items, like we are joining these two tables, we are joining tables here, and at the end from the fact orders and the dimension restaurant, we are creating mart. So this gives you the complete visual understanding of how your data actually is created. This is a lineage graph, and this is what makes dbt powerful, so that you can actually see how your data is moving across the entire pipeline. So this was the core of DBT. Now the Streamlit part, we will do it when we are actually doing this RAG and text to SQL. We will actually try to visualize that over there. But the core of DBT is finished. Like core of our first pipeline and the first layer is finished. Now what I want to do, I want to orchestrate this using Airflow first, and then we will start moving with AI part, and then we'll finish the entire project. So this is just 50% of the project yet finished. Now we have to go 50% more, and here we will try to spend more time understanding the different things. But this is the 50% of the project we have completed, which is a simple data engineering ELT pipeline. We loaded the data, we executed the entire DBT model, we created the connection between DBT, Snowflake to AWS. We did everything from start to end, and we are able to reach here at this point. So if you're still watching this video, congratulations, you have completed 50% of the video. Don't forget to hit the like button if you did not, and let's move forward to the next one. Now the next part here is configuration of Apache Airflow. That is very important. If you don't know what Airflow is an workflow orchestration tool, just like DBT, right? It is used for transformation. Airflow is used for orchestration of entire pipeline. So if you want to run this entire pipeline step by step, like upload the raw CSV, build DBT core, enrich reviews, and all of the other things, you can easily do that in Airflow. So let's just try to do that. And the configuration is pretty simple. I have the files available for Airflow configuration. So what I'll do, I'll just get them. So okay, you can just let me just create a new folder as Airflow. You will find this on GitHub directly, and then there is a docker compose.yaml, and I'll paste the content. Let me just copy this and paste it here. So this is the entire Docker file. Don't worry about that right now. And then we have this new. We'll give this Docker file, and let me just paste this Docker file. Other than that, we need a DAX folder. So I'll create a new folder as DAX, and this is done. You can also create environment folder. So let me just put dot environment, and I will just put all of our environment variables at here. This is fine. I think, yeah, this is pretty much what we need. So what I'll do, you can open a new terminal here, go to Airflow, and you need Docker in your desktop. So if you don't have Docker, you can just go online and just search download Docker desktop. It is available. You can just install it on your PC. Just do next. It will automatically configure. And once you have Docker installed, so first of all, let's just put the, I think we need some environment variable. So what I'll do, I'll just write our environment. So we need three things: Snowflake account, then Snowflake user and Snowflake password. Now, one, you can put it inside the Airflow connection string like Airflow variables. It is possible, but let me just put it right now here itself, because again, environment, putting it on environment variable is also a secure way to put your credentials. So password, I'll update the password as here. Username is this, so I'll add this here. And account, right? So account, we have this one. So let me just paste it here. This is done. And then I will do docker compose build. So open API key is, I'll add it afterwards. So this will just start downloading the all of the images from online, and then I'll just have to write docker compose up dash d, and this will start my Postgres server. So I'm just waiting for that. It is creating Postgres. Also, this will start my Airflow server. It's been long. I've been recording this video, so my mind is not working. What I want to do, I want to finish this Airflow section right now, and then after maybe after a break, I'll start working on the AI section. So my Airflow server is running. I have to just go here, localhost 8080, and you will see this. Let me explain you a bit what we just did here. We have the Docker compose file. It pulls, first of all, we have the Docker file that gets the Airflow latest version. After that, it installs like the important libraries such as Snowflake, there is Apache Airflow providers, Snowflake, Fab, and OpenAI, because I will be working with the OpenAI API. And then it creates some virtual environment over here to install the dbt Snowflake to run the dbt command. And after that, we have our Docker Compose YAML that has all of the configuration. But main configuration that we are interested in is Snowflake account, username, password, OpenAI API key, and the sample. This two, we will do it after we create our first DAG. Then when we start working on the AI part, we will understand about this part, but everything else is fine. We don't have to do anything else. It also has like dbt, let me update the, it also has this dbt Zomato mounted to our Zomato project folder, which is over here, right? So that has it has, I think it should be Zomato to Zomato, right? Inside it is Zomato dash dash AI. We don't have it right now. Logs and DAGs are available. DAGs are available. Yes, yeah, this is fine. I think got it perfectly. Let me just restart the server. Docker compose down, and I'll run it again. Docker compose up, and this will start one more time. Just waiting for it to finish. Okay, so the server is running. Let me refresh this one more time. Localhost 8080. Once this is healthy, I think we'll see it available. Yeah. So you can just write admin here, and this is the new UI of Airflow 3. Again, most of the things are same, nothing changed here. You can just, this is your dashboard section where you can see the failed DAG, running DAGs, and active DAGs. All of the things are here. Then you have like different DAG sections, assets available, and every single thing. This is like same as what we had previously, but the UI was different. What I need to do is I need to create a new DAG here inside my DAG folder. I'll go and create a new file called as Zomato underscore batch dot Python. Okay, we'll just try to write this quickly. So for example, from date time, import date time, from Airflow import DAG, from Airflow dot providers dot common SQL dot operators. I have the SQL executor query. From Airflow dot providers dot standard dot operators operators dot bash. I have the bash operator. Like these are the two operators that I want to use. Could not be resolved. I think this is fine. Now, what we are going to do ultimately in Airflow, again, I'll just give you the quick understanding that we will run every entire pipeline onto our local PC. We are not going to run it on the cloud because again, it will cost money for no reason, and we will have to deploy our all of the projects. So we are running it on our local machine itself. Whatever we did in on the Snowflake, it already installed the Snowflake package, so we can use that directly and start executing it. So first thing, you have to define the dbt project. So these are the two things I have to define where dbt is. So inside our Airflow, it is here, and opt Airflow dbt is Zomato. Like dbt project is inside the Zomato. So dbt project is inside mounted when we ran this. Let me just show you one more time. These volumes are mounted. So this our Zomato project is mounted over here, right? So automatically inside the Docker, it will be able to access all of the files. Then let me just put this here so that we can see. So we will define a list. That list will have information and all of the code that we ran onto the Snowflake console. So use warehouse Zomato warehouse, then copy into restaurant food all of the tables from the stage that we defined, and the exact command that we ran on this uh, over here. Like this is the exact command that we ran. All of the commands that we ran here, all we are doing is just putting them here. Nothing changes, and then we define with dag uh, dag id as is equal to Zomato batch. Start date is fine. Schedule interval daily. Catch up false. We'll just add tags is equal to, for our reference, Zomato batch dbt. Doc md as underscore doc. Okay, simple as dag. Now what do we want to do? We want to first run our load command. So whatever the raw data that we are getting, we want to load that onto then we want to run our dbt project, and then after that we will run the AI pipeline. So right now we'll just do the two things. First is reload raw is equal to SQL query operator task id reload raw. Then we have connection id is equal to Snowflake default, comma, SQL is equal to copy raw. This is the copy raw SQL we have. And after this, split statement true, auto commit should be true, and that's pretty much. So this is my first task inside the Airflow. And the second task will be dbt build core is equal to bash operator, task id build dbt core. Bash command is dbt build we whatever the project directory we have that we have defined on top. This is the project directory, okay, and profile directory is this. Wait, dash profile directory, and I think this is fine. And yeah, and at the end we have to define the dependency. So it is reload and build dbt code. Let me just see. Dag is here. It is showing some error. Do we have some issue? Yeah, comma here. This is fine. Now if I go to Airflow and refresh, let's just see there is one DAG and there's an issue and got schedule interval or daily false. It should be just schedule, not schedule interval. If I refresh this, so one of the DAG is available here. What I'll do, I'll just click onto the trigger, single run, and we'll see uh, these are the two tasks we have. So first task, we'll see if it runs or if it fails. Currently it is in queue, so this is running. Let's just see onto home. So running, okay, the one was already running, so it's two successful. Two is running, two successful. I think our DAG will be successful. If I go here, uh, this is running. Okay, both of them failed. Reload row, this worked fine. This worked, but this one failed. So let me just see what happened. The issue is tag loaded dbt build help dbt option invalued profile dir does not exist. So what I'll do, let me just not put the profile here. I'll just keep it like this. Okay, and let me see if the code refreshed. Let me run one more time and see what happens. So this is running. This ran when this failed. Oh, cannot find profile name Zomato. Oops. Okay. Failing DAG bag, DAG bundle, OPT, Zomato, hooks, info error, source task, return 0, operator, is XCOM. What is this? Could not find profile name Zomato. DBT profile, DIR, OPT, Zomato. Okay, cannot find the profile here. What is happening is that in order to run DBT, we need the profile because it has all of the credential. So what we can do here is inside this Zomato folder, we can just bring the this profile YAML file. We can just write command as cp tilde slash dot dbt slash profiles dot YAML, and we have to put this here only. So profiles dot YAML. Okay. So what will happen inside our Zomato? This profile YAML will come here. Now this will be mounted to, we already have Airflow mounted to this folder. So it can automatically read it. Let's see now what happens. We are going to run this one more time. So the first one is running. We are having issue with the second one. So let's see uh, this particular task. This is successful. We go to DAX. We come here. This is fine. Task. This is successful now. So as you can see, it ran successfully after it was able to find the profile, and everything is passing. All of the views are getting created. All of the every single thing of the dbt command is running. So this part of the first two things. Let me just update this. Running uploading raw data and running dbt core is working. What we are simply doing right now is just we are loading data back to the Snowflake, and then we are running dbt again on top of it, so that what we are really doing is that we are running our Snowflake load command over here, which is like copy raw data from the S3 bucket, whatever the data that is there, We put that onto the Snowflake, and then we put that entire thing using dbt to orchestrate it. So we run the dbt from the local, that will execute the dbt command one by one, and we get our entire Marts and dimension model created. So these are the few, this is the actual part of the pipeline that is done. Now what left is working on the AI lane, which is the three capabilities that we were talking about: LLM enrichment, RAG, and the text to SQL. This we will start working now. So first we'll understand the theory, and then we'll start about building this entire part, and then we'll building the this part. So I did not spend time explaining about the Airflow, but if you want, you can always see and go to Airflow course, and you can understand everything about Airflow fundamentals from UI. This is more in-depth course available on Airflow. So if you want to master Airflow for fundamentals, intermediate, and production Airflow, you can come here and master it. But now we will move to the next step, which is understanding about the LLM side of the pipeline. So till now we have completed this first layer where we ingested our data onto S3, then loaded that data onto the Snowflake, build the entire pipeline till here, and also orchestrated that entire part using Apache Airflow. Now what I want to do, we want to focus on this AI part where we will work on three layers: LLM enrichment, RAG pipeline, and text to SQL. These are the three things we will do, and we'll also understand some of the foundation concept of AI. Now, before moving forward, I just want to clear this, like this is not a complete AI course. So I will give you good enough understanding. Like you will understand most of the things, but in the next videos or in the future videos, I will create a separate video on AI data engineering masterclass for data engineers for overall data domain, where we will deep dive into all of these things on a technical aspect. Right now, I'll give you the applied side of understanding how do you actually use these new AI tools to integrate in the system. Because we need to understand that, right? AI in data engineering does not just mean generating code. That is just one aspect. What we need to understand is how do we integrate these AI models into the pipeline so that we have a better serving side. What does that mean is that, for example, in our case, we will have reviews coming. So earlier, if I wanted to understand what this review meant, I will have to maybe train my separate I will have to train my separate machine learning model with the classification or regression or whatever it is, right? I'll train my neural network so that I can find the sentiment of the reviews or try to understand. Now I just need to understand how do I put this into the pipeline, feed it to LLM so that serving side can get the direct data from that. So these are the types of things we will be doing with the AI, where we try to integrate AI into our data engineering pipeline so that we get AI driven output, and we'll understand all of this as we move forward. So I just wanted to make it clear that again, we are not going to deep dive on the technical aspect. We are mainly focusing on the applied side of it. So with that in mind, let's start. Now, in our case, we'll use the OpenAI API. Now, it doesn't matter. You can literally use Claude API or any open source API that you want to use. Right now, we'll work with the OpenAI API, and we will try to understand what are the different things in order to execute this project. Now, why AI belongs into the data pipeline? That is the first thing we need to understand. Now, classic data engineering things, if you know, like we usually process the structured data, like numbers, category, timestamp, everything till now. But what if we have like huge text data available, such as reviews, tickets, chats, PDF, all of these other things? We could not do all of these things. Second thing is SQL can't understand the meaning, right? When you write something, let's say select star from count reviews, the system does not really understand what this means. Like it just executes the query and gives you the result. Now it cannot tell you about the review that is angry on you because of the late delivery. That gap LLM closes, right? Till now we wanted to work with the data. We just write a query, we get some output, and we are done with it. Now AI can actually give you what you ask. For example, a customer is angry, and also because of the late delivery, find me the customers who are doing this, right? So it will fetch you the list without you asking or without you preparing all of this data. It will directly do that for you. So this is the power. And the third, the AI data engineer. How does the AI data engineer works? That I already explained you. So it plugs an LLM into the pipeline just as another transformation and builds app on top of the warehouse, not an ML researcher. Like, we don't have to train machine learning models and do all sorts of things. We just need to learn how to integrate these tools into our data pipeline and try to serve it better. So you can put it onto the transformation layer to transform some of the data, or you can just put it onto the warehouse side to serve the data. That we'll understand. Now in this part we will build three things. First is enrichment, which is the LLM reads every review and writes the sentiment, whether it is a positive or negative, and plus topic columns back to the Snowflake. So feelings become queryable. So if you want to query based on the feelings, you can do that. Second is a RAG, which is basically your chatbot on your data. So chat with your reviews. So you can actually search like different types of reviews by chatting with the uh, LLM. And third is text to SQL, right? Instead of writing SQL query, you can literally just chat with the data warehouse and it will write the entire SQL query for you. Or not a SQL query, it will write the SQL query in the backend, but it will directly fetch you the output, whatever the things that you write. So these are the three things that we'll be working on. Now, let's understand some of the basics before we move forward, where LLM sits into this entire universe. Now, understand this, right? There is artificial intelligence, which is like complete field. Machine learning, where you give data to system so that it can learn. There are two types. One is supervised and second one is unsupervised. Right now, again, I'm just giving you overview. So in future videos, we'll deep dive into it. Supervised learning is basically you tell machine what is the predictable output, and unsupervised, basically machine learns by itself. And there's a deep learning. So deep learning is one way you can train machine learning model, and in that we have LLMs, like large language models. So the only thing LLM model knows is to identify the pattern, and we'll understand about that pattern in the next slide. But this is the core of LLM. It is just trying to predict the next word, high likely word. So the core of LLM is to just predict the next word. And how does it do? Based on the massive text data that is it is trained on. So all of the knowledge around the world, right? Every single GitHub repository, every single book, these companies such as OpenAI, you have the Anthropic, you have Google, Meta, all of these company has this large GPU cluster running onto data center, and these data, like around world's data, they are feeding to this LLM model so that it can generate the pattern and start predicting a better next words. So for example, the biryani arrived cold and the rider was 40 minutes. What is the next likely word in this sentence? Most likely it is late, right? A biryani arrived cold and rider was 40 minutes late, not early, because early doesn't make sense here. So job of LLM is to just predict the next word. For example, let me show you with visually how it actually looks. Yeah. I've added some images to explain you this part very simple way. For example, first is the data collection, right? You collect data from all around the world. You have data coming from books, website, article, code, many more things. So all of these companies around the world, they already have the data and they're trying to find more and more data. Like, you might have heard Anthropic crawls the Reddit website, it crawls the Stack Overflow to get all of the code and every single thing, right? All of these AI companies just try to get as many as quality data so that they can feed it to LLM models. Then comes the part of pre-processing. Now, pre-processing is basically you try to divide your data into tokens, which is basically you divide them into the chunks. So this is then raw text, like LLM are amazing. Now you divide them into tokens. Basically, every single word becomes a token. So LLM is one token, R is one token, amazing is one token, then exclamation mark becomes a one token. Then it goes into the training model. Training model, again, we'll understand the little bit detail about it, but training model is a transformer model where you feed the data, model learns the pattern. So all of the text that we are feeding into the transformer, it will learn. Like there are billions of tokens, like you can't even imagine how big uh the size of the data they feed it into, like billions and billions of tokens. Like if you go online and check the size of, let's say, Opus 5 model, uh, and you will see it has like 1 million context window. This is fine. So over here, if you see the size of the parameter, uh, s- size of uh, parameters of Opus 5 model, and you will see somewhere they have written or published Opusify. Let's just go with the meta model number. Now, when you see all of these numbers like 7 billion, 13 billion, 70 billion, what it really means is that the size of the data, the parameters, basically the amount of data that you feed into this transformer model, and this model actually holds all of these patterns inside one single container. So whenever you input something, it will predict the next likely outcome and it will keep giving you different results. Then comes the part of fine tuning. Again, this is an optional thing. Basically, if you have a specific requirement, let's say if you want to fine tune a model for writing a better code or writing a better article or writing something better books or whatever it is, like if you have your own use case, you can fine tune a model. Now, fine tuning is again an expensive process. Usually we can't, if you need like a high cluster and GPU in order to fine tune, and it will cost a lot. And then this is more of a inference. Inference is basically you give the prompt, model guarantees the response token by token. So why is the sky blue? It will go into the LLM model and the response will be generated. The sky looks blue because then other token, right? So inference is whenever you ask something, you are talking to a model. This is like inference, and it is giving you some output. And at the end, again, you get like complete output from the model. So this is what the core of LLM looks like, right? Basically, you have your data, then you pre-process your data. Basically, you divide your data into chunks, then it goes to a training model, that you fine tune the data, then inference comes and the output comes. Very high level right now, just to understand the core concept. Now, the question is, what happens inside the model? You might ask, right? What is happening inside the model? And this is where the concept of token embedding comes. We'll understand about the token embedding in a little bit detail, but right now just understand how it is working. For example, this is a text. Why is the sky blue? Question mark, right? This is a text. So tokens like these words are converted into the vector numbers. Like these are the numbers that we don't really understand as a human, but computer can start finding the patterns around these numbers, and these are the positional encoding. We'll understand about the positional encoding when we understand the embedding in a little bit detail. But understand, like there is a graph, and on the graph every single this number has its own position similar to other words. Right now this is enough to understand, right? So all of this encoding data is fed into this model, the LLM model architecture, and its job is to predict the next token or next word. So the way it works, why is the sky blue? Question mark. So it goes to the transformer block and it generates a next word, basically likely word. Like blue has the highest probability, so this will go again inside the model. Again it will generate the next prediction. Again it will go inside the model. Again it will generate the next prediction, and finally you will get the output something like the sky looks blue because of this whatever it is, right? So this is how it works. So this is a simple example, like why is the sky blue? Sky looks blue because of relay scattering. And then it starts generating next token as you start talking to it. Again, this is the core idea of how it works. Now the key points: LLM don't understand like humans. Okay, the only goal of LLM model is to predict the next outcome. That is all LLM do. In simple word, it's like a lot of reading, finding patterns and predicting the next word. And these are the popular LLM models. You have the GPT, you have Gemini, Claude, Llama, and Mistral. Like there are a lot of new open source also available, but these are the popular ones. Now let's try to understand from the last example that we saw, right? So it is trained on the massive text. You put all of this text into LLM, and then LLM start recognizing the pattern. One objective, many skills. So it can summarize, it can classify, translate, reason, write. All of these things LLM can do because it has all of the knowledge available. So the way it works, the token prediction, for example, the biryani arrived cold and the rider was 40 minutes. Now this text is divided into different tokens. We will do this when we build our example. So this gets feeded into the token, and there is an embedding model that actually converts these tokens into the numbers. Once it goes into the LLM, it will generate the probability of the next word. So out of all of the token, like late, delayed, away, busy, whatever, the late has the highest probability of 0.92. So it will be added here. Again, it will go back to the main. If you are asking more and more questions, it will keep repeating the entire process and start predicting next token in the backend. So again, LLM does not understand like us. They just predict the next word based on the token that you put. Now, when we use all of these model, we don't have to train them. All we have to do is just call them, because it is done by all of these companies like Google, Anthropic, and OpenAI. Like foundation models, we just call. We do not train them. If you have a specific requirement, you can train it, but again, you will need a lot of capital, lot of compute power in order to train, and also a good chunk of data on your knowledge. So for that, we have like multiple things. We have the RAG pipeline that we will do. RAG is basically you feed your own data into the LLM and try to get the output that you like. So there are multiple ways you can use this LLM. So these are the foundation models, like we call, we don't train. Basically, provider trains the foundation model like OpenAI, GPT, Anthropic Cloud, Google. All of these company uh, spend enormous amount of training all of these models, and then they give us access using the API. So provider trains the model foundation, and then you can access it via the API. Why we don't train the model? Because we need massive data, we need thousands of GPUs, research team, months, years, and huge costs. But if you already have the foundation model, you just need API and lines of code, and you can start using it. So it makes the life simple. And again, it is pay per use. So amount of input token and output token that you put, you get the response as per that. Now talking to LLM is quite easy. There are some rules: user data and assistant reply. So this is the format. We'll understand about this when we actually write the code, but it's pretty simple. You define the role of the system, that okay, you are the system who classifies the food delivery sentiment. Then you give the role, you add the text data, and it will start giving you the output. So set the rules and behavior, provide the actual input, and it will give you the output. So I assume you have already used like ChatGPT or Cloud type AI interface. When you go online, when you type something, right, you always tell model that pretend to be like a data engineering expert. If you want a specific output, let's say if you want a marketing related output, you will tell the AI that okay, act like a marketing expert and then give me the output. So it is more likely to do so it is more likely to give you the correct output if you ask properly. So this is what it is like. You have to set the rules and behavior, then you put the input and you get the output. Now, these are the few things we need to understand while we are calling this LLM model. One is the temperature. Depends on the model type that you're using, but temperature controls the randomness. Like if you keep the value close to the zero, it is more stable and repeatable. If you keep the value to till one, it is more creative. This is just one parameter that you have to feed. Most of the new models does not have the temperature parameter. They keep changing, so it can have, it might not have. In our case, we'll use the model as GPT-4o mini because it's the cheapest and the fastest model available. We don't want to spend like huge money onto this small project, but you can literally use any model. There are like a lot of different models available online. You can use any model and you'll get the output as per the model that you choose. Again, we understood the what model is. Model is basically the amount of data it is trained on. So GPT-4o mini might be trained on like smaller parameters, and it is designed to give you the output faster. There might be model like GPT-4, GPT-5. So GPT-4 is trained on, let's say, 1 million parameters, and GPT-5 is trained on, let's say, 10 billion parameters. So all of these things matters, and the output quality differs as per the amount of data it is trained on. Okay, so this is the core of the foundation model. So we understood the core foundation. Let's quickly understand about the context window, like how much model can process. So if you see in recent days, Anthropic and most of the companies gives you like 1 million token context window. So a model can remember 1 million token at the same time and process the data. In the earlier launch of these, like GPT models, the model has like small context window. So whenever you used to talk to the model, you have to keep reminding the model that we are working on this task again and again, so that model can remember what we are doing. A lot of time it will start hallucinating. What that means is that the work that you are doing goes out of the context window. So model starts forgetting what we are really working on and starts giving you random output. Like even if you ask something, it will completely give you the random output because the context window is quite small. Context window is basically how much model can see at one time or how much model can understand. A context window is a maximum token a model can see at once. Prompt plus data plus its own reply all inside one budget. It's like a simple window that model can put all of these data at once and can understand. So you can't dump 300k reviews directly onto the model and just expect that it will start working. right now you can dump because the context window has increased to 1 million, but if you try to put like 5 million text word token, it won't understand everything. Remember this limitation, because this is the reason RAG exists. Basically you retrieve your data and try to feed while you're running your pipeline, so that it can actually give you the output based on the data that you have entered. So in our first example of LLM enrichment, what we will basically do, we will read the data from the Snowflake, we will pass that data to a model, and we will ask it to write me a simple sentiment on that particular topic. It is pretty simple, and then we can actually query that information onto the Snowflake. So very simple ELT pipeline that we will execute. So this is the core idea that what we will do. Now let me explain you a little bit about embedding, because this is quite important to understand, and this is the most difficult part to understand. Because as a human, like whenever you're trying to learn about this AI, we always think about how does AI actually knows that food arrived cold, freezing biryani late, all of these words relate to each other. How do AI model actually knows? And the answer is embedding. Basically you convert your text into a pattern driven numbers, and each of these AI companies like Anthropic, OpenAI, Google has their own embedding model. There are multiple versions of it that they have built so that they can train their this LLM model on top of it. So we'll just quickly understand how this works from the top level, so that we have a clear understanding what we are doing. So if you have a basic computer science background, you know, right? When you try to search something on a search bar, and when you try to search it based on the text, for example, you search something like freezing food. So what as a text it will try to do? It will try to find the exact freezing food text into the whole database that you have and give you the result. But embeddings does not work on a text basis, they work on a meaning basis. So when you search freezing food, it will try to convert this into the numbers and then try to find the patterns and give you the result in the text form. Something like if you search freezing food, it will give you the food arrived cold, freezing biryani, meal lukewarm, something like that. So embedding captures the meaning of each and every word. So models basically understand what freezing, cold, all of these words mean, not literally like human, because we understand what the cold, hot, and all of these feelings actually mean because we have experienced it. But model has the some idea or some pattern inside it that we don't really know right now, because it is a complete black box. So we don't know if model actually understands it or just trying to predict the next word. So the way it works, it's something like this, right? If you put it on a graph, all of the words that are close to each other, for example, food arrived cold, freezing biryani, meal lukewarm, will be closer or clustered together at one place. Or again, this will be converted into the numbers, so this will be clustered together at one place. And just like positive reviews, like, you know, on the love the new app you are, great discounts or whatever. So the amount of words or amount of tokens that are close together, that has the similar meaning, and the different words will have a more larger distance. So right now these things are clustered together, these things are clustered together, and it will be clustered based on the embedding model. So it works like this, right? This embedding model is designed by this company, but there are also a lot of open source embedding model that you can use. For example, there is a text food arrived cold. Now this will go inside an embedding model, and this will be converted into text like this. Now we don't actually understand what this text is, but this text machine understands it. We don't understand, we understand text, machine understands numbers. So this each and every individual word is converted into like vector embedding that is plotted onto the graph, like high dimensional vector graph. So human can't understand what these number, but AI understand the meaning from them. They try to understand the meaning, and this is how it works. For example, when you type like freezing cold, it is converted into the embedding. It compares with all of the embedding from the database and try to find the similar words in that graph. For example, when you saw like food arrive cold, this will go inside this part of the graph, like one cluster, and will try to find the similar words from there, and will predict the likely outcome from there, and it will return the best match out after this. Again, this is the core of embedding. Now let me take you one step further into this to explain you into a little bit more detail so that you understand. I don't want to go into the mathematics side of it because it is too complicated right now to explain, but we'll just get the good enough idea so that out when you complete this video, you understand at least that okay, this is how LLM works. I'm not master of it, but I have a good awareness about this particular thing. but I feel good that, oh, this is just a model, this is how it works, this is embedding, all of these things. The words that you need to remember after this video, all of these things will be cleared, so that in future when you hear all of this, you don't get scared. You will be like, okay, I know what embedding means from the top. I know what LLM means from the top. Everything you will have a good enough idea. We will go in depth when we create a complete masterclass for AI data engineering. But for now, this is good enough for this project. We'll go step by step. Okay. So similarity is equal to distance. So just remember this. There are different number like cosine similarity numbers that are given onto the graph. Like if the value is closer to 1, which basically means it is very similar. It is 0, that is means it is not similar or unrelated, and -1 means opposite meaning. Okay. So on the 2D space, it looks something like this. This is a multi-dimensional, but right now we are trying to understand this into the 2D space. So for example, cheap flights, budget airfare, low cost, all of these are very common. So it is centered into the one cluster. Same goes with the healthy salad, fresh vegetables, nutrition food, and same goes with the this cluster. Now, if you see the similarity score like 0.2, okay, cheap flights budget, it is like 0.2. That means it is sort of unrelated or little bit far. It is minus because it is completely different topic in itself. Like quantum physics has nothing to do. Quantum physics, wave functions, Schrodinger equations is completely different from low cost tickets, right? It is not similar at all. So that is the reason the similarity score is -1. Here it is like 0.2 because it has some similarity but not that much, so that is the reason you are giving the score as this. How does this work? We already know about this. For example, you have your text, you have your embedding model available. It goes inside that, it generates like the different embeddings. Then you can either put this information onto the vector database. We are not going there right now, but if you put that onto vector database, you can do a similarity based search. So based on a text, you can try to find the similar words, or you can chat about it and generate the next token. So these are the two things you can do with embedding. One, you can do the good search, like when you want to search based on the text and find the similar information, you can do it. Like when you do a Google search, right? Simple. Even if you do something, it will give you the information that are related to what you have searched, not exactly based on the word, but the similarity of that word. So that matters a lot. So this is what we call it a vector search. And second is chat and LLM that we use on day-to-day basis to chat with the AI chatbot. Vector store works in a simple way. You have a documentation, you again create the embedding models, then you store that embedding onto the vector database. So whenever you search anything, it will go search from the vector database and give you the right output. I don't want to go into detail right now, it will confuse a lot. We will have a dedicated section in future to understand this. Now this is the last thing that I want to make you understand before we actually start doing the hands-on practice, is RAG, which is retrieval augmented generation. The name sounds quite complicated, but it is quite simple. There is a LLM model, there is your own data available, such as I have my own YouTube scripts that I wrote way back before the AI, right? So I used to write everything. Now I can feed all of these YouTube scripts to the AI model and tell it to remember my patterns of writing, the way I write, the story that I use, and everything. So it will learn from that, and then it will give you the output. That is all the RAG is. You just try to feed the data inside your prompt, and it will understand based on that. The name sounds complicated for some reason, like RAG. People say I have built a RAG pipeline. It's nothing. It's nothing. It's just you feeding your own custom data into the model. That is all it means. You are not fine tuning it, like you are not training it completely. All you are doing is just feeding your data. Okay. So again, LLM has never seen your reviews. In our case, LLM has no idea about our reviews, like what it actually means. So it can't actually see what it is. If you ask LLM about it, it will say I don't know. It will just give you the random output. So to fix this, what do, you just try to feed your data to LLM model. Okay. And then based on that, it will start giving you output. So LLM alone does not have the access to your data. RAG is basically the facts that you have, such as your relevant data, ask and getting the answer, like whatever you want, and then it gives you the answer based on that. It works in simple way. First is embedding. Same, you have your data, you put that into the embedding model, and the vector embeddings are created. Then You ask AI like the questions, whatever the user have, like retrieval questions. It goes to the embedding. You will do all of the vector search, and it will give you the matching output, and then LLM will generate the answer. This is the entire thing we'll do with our data, right? The RAG pipeline that we are talking about. We will use the embedding model. We will use the chat application to generate all of this. So these entire thing that we understood, right? It needs a complete dedicated video if you want to deep dive into the technical part of it. But what I wanted to cover using these slides is to give you the confidence that AI is not that difficult from the applied side. Like when you are online and when you see like a lot of people are talking about inference, embeddings, RAG pipelines, there are so many big jargons these people try to throw at you to make you feel that you don't know anything. It's not that complicated if you just have your foundations clear. If you just try to understand, like I explained you RAG, right? RAG is simple. You retrieve your data, okay, you augment it, and then you generate it. The words are quite difficult to understand, but when you actually see it in practice, it is nothing but you feeding your data to a LLM model so that it can give you the right output. That is all it is. Embeddings are basically you feed your text data, divide it into tokens. You have your data, you divide it into tokens. It will convert this into the numbers. Again, you can deep dive on how it generates a number, how it plots into the graph, and all of sorts of things. But this is the job of AI researcher who spend time reviewing AI and trying to find the answers or trying to find a new things. From a person who is using the application side of it, you just need to first learn how to use this in your entire system and try to make best out of it. And this is how you get a job in market also, right? When they ask you, you know the core theory, but you also know the applied side of it. And if you are someone who wants to be a researcher and AI researcher and want to work on this firm, then there's a separate path for that where you actually try to learn the mathematics behind it and try to understand the architecture and all sorts of things. All you need to do right now is just how to use them. We'll talk about all of the mastering things in maybe future videos, but right now this is the good enough understanding that you have. And if you actually understood till now, like if you like this explanation, then do let me know that you actually reached to this AI section, because this has been a long video till now, and I'm not sure how many of you might have reached here. It's like teeny tiny percent of people, like even like 0.5% of people who might be watching this video at this point. So if you are someone who is watching this, comment below that I reached to the AI sections. uh these will be the like small group of people, so you'll know like, okay, this person is actually doing and trying to learn this entire thing. So this was everything about the AI. Now let's actually start building it. Let's start doing the hands-on practice to see how it works. So all of the PPT I've explained. Now again, these are the AI vocabulary that you can understand, like LLM, prompt, token, all of the sorts of things. We don't want to worry about it. Now all we need to worry about right now is writing code and start executing this three layers that we talked about, like LLM enrichment, RAG, and text to SQL. And these are going to be quite easy and difficult at the same time. If you know the basics of Python, it will be quite easier to work with. So let me open the this. uh, I have this AI folder created. You can create the AI folder if you don't have. And now I will create my first pipeline, or the first file, enrich underscore reviews dot py. This is the first Python file that I create. Now there is one thing, I can just write the code with AI. I can just tell the AI to write the code for this data, it will generate. But more than that, what I want to explain the concept to you right now. So what I'll do, I'll try to write this code by myself and then explain you one by one what we are doing, so you'll have a better understanding how it works. So we'll import some of the functions such as import OS, import JSON, because we'll be working with the JSON data, import Snowflake dot connector, and from OpenAI, import OpenAI. Now these things I might already have it on my local PC, but if you don't have, you just have to do pip install OpenAI and pip install Snowflake, and you will get it. Now the first thing we have to define is model, and in our case we'll use the GPT 4o 4o mini one, because it's the cheapest one and the quite fast one. So in the first example, what we want to do, we want to understand the sentiment of our reviews. So we'll first define the sample size of the reviews that we want to work on. So first we'll do it for 5 reviews. Then we can like, we have around 300k reviews available. We don't want to run entire pipeline on 300k reviews. We'll just do it on 5. The first step here is we have to define a client and create the OpenAI uh, object. Right now, I don't want to put my keys here. Once we define the client, we need to put the system prompt, and it looks something like this. I'll have a system underscore prompt, and here let me just write this into like this. Here in between, we will write so you classify customer reviews for a food delivery app. For the review you are given and written first sentiment label as positive, negative, or neutral. Then a sentiment score, that is a number between minus 0.1, minus 1.0 and 1.0. Then a topic, one of one of topics that we have to define, and then key issue, a short phrase of 6 words or less that describes the main issue. If there are issue, then return null. I'll just say null, or yeah, I think null is fine, something like this. You will find this onto GitHub itself, and then reply as JSON in this exact format, which is sentiment label, sentiment score, topic, and key issues. That's it. So what we just did is just we have given a one system prompt, and the topics we have to define. So topics such as like, yeah, food quality, delivery time, customer service, app usability. We can give something like delivery. We can just give food quality, uh, delivery. Then we have pricing, about service. Mm, uh, Other things are in the food deliveries, packaging, and let's say other something like this. Okay, so these are the topics that we want to measure our entire pipeline, and this is a system prompt that we have given, that you are a customer's review for a food delivery app. You classify, yeah, you classify customer, this is key. Yeah, sentiment label, sentiment score, so it will give us like sentiment positive, negative, neutral. It will give a number between -1 to 1. It will from these topic like food delivery issue, delivery, food quality, pricing, service, and then it will give us like the short key issue, like what is the issue here, and the entire prompt is given into the, it should return into this format of JSON. This is what we call as a prompting, and at one way this is sort of a RAG, but this is more of a, we can think of it like we are giving a prompt as per our own requirement. Okay, so after this we want to create a connection with our Snowflake account, because first we want to create table, fetch the data, and feed it into this model. So let me first import from, on top you can go from dot n import load dot n, and here we just have to do load n, and let me just create new environment file here, env, and we can just put all of our information that we had into the proper structure. I think we have it on Airflow also, so let me copy that information. I'll copy it, I'll paste it here. Account, user, and password is here. Snowflake, Snowflake warehouse, Zomato warehouse, database, and schema. We'll give Snowflake schema as AI. Now we can just get this information and use the function, for example def get connection, and here we'll connect the like snowflake.connector.connect, all of these are coming from the environment, so we get it from there. So using the syntax we can get the connection variable to connect with the Snowflake. After that we also want to create output table, uh, so that we'll send the connection information here, cursor, and we'll have cursor dot execute, like first cursor dot execute, uh, create schema, if not exist Zomato dot AI. If the schema does not exist, we will create the new schema. Then cursor dot execute, create table, if Zomato dot AI enrichment. We will just give the name as review enriched, and then we'll give review IDs, sentiment label, sentiment score, topic, key issues. We also give the model information, so model as string, and reached at timestamp, and we'll give the current timestamp, something like this. So basically we are just creating a table, same using the create table statement, and we try to put all of this information so that we cover like review ID, sentiment, score, topic, yeah, cursor and cursor. Okay, so model and enriched at, so timestamp, so we always know like when was the model we ran, and when the review came. So this is where we will put the enriched review, like the sentiment score, but we also need to fetch the review from our review table. So we will do get reviews to en enrich, and again it will have cursor sam uh, cursor dot execute, I think review ID review, and we have comment here onto our Snowflake. Let me just go here. Here it is. If I go to Snowflake for our, let me open a new file, and you don't have to open a new file. We can just go to database, onto our AI raw. We have reviews available. You can just do the data preview, and you say review ID, order ID, user ID, restaurant ID, rating, comments, and review date. So what do we need? Review ID and comment. So we'll just get comment from Zomato raw reviews, where review ID is not in enriched, so we don't want to process that this again, and limit sample. So we just want to do the sample of the data. So yeah, this is fine. Return cursor fetch all. So this will fetch all of the reviews. Now once we get the reviews, we want to classify the reviews. So def classify review, classify review comment. So we'll just pass the comment, and we have to, here we will just start writing the model thing that we understood, right? How do you actually pass to the model and get the output? Here we have to call our model, and it's pretty simple. We do response is equal to client dot chat dot completion create. Now this is a function given by the OpenAI. So if you do the OpenAI chat, and if you go to documentation, you will find this function. Let me show you that. OpenAI API completion function API, and here you will see it's like client dot completion dot create. So if you want to pass a text, and if you want to complete that text and get the output, you can directly use this. You like insert the text, and then it will give you the output at the end. Again, if you want, you can read it in detail. So we are just using that here. So dot create, then you have to define your model. Model is equal to the model that we have defined on top. Then temperature we will set like stable one, which is 0. uh Response underscore format, we have type JSON. We have JSON object will give it the JSON object, and messages is equal to role. See, we have to give the role system. So content, whatever the system prompt that we have defined on top. So this is the role of the system, and the role user, which is a content, which is a comment, right? Whatever the input that we are given. So these are the two things we are giving. We have to define the role of the system. We have to define the role of the user, and this will give answer is equal to response dot choices dot message dot content, and return this as JSON load stored answer. So this will come into JSON, and we'll get the we will extract the list out of it and all of the content out of it. Once we run this, we will see the output. But this is the overall idea, right? What we are just doing is we are just calling the model. We add the model name, temperature, type. We define the role, and we get the output. Once we get the output, we want to save this output to the created table above, and it works like this: def save results. We will have cursor and results, and we'll just do cursor dot execute many, insert into this values. This, let me just uh result. Yeah, this is done. So this is like insert into review idea, sentiment score, a topic, key issue, model. Into this, I think, yeah, this is fine. Topics, key issue, model, and value. And then we have to call all of these. So we'll just do def main, wait, main connection is equal to get connection. Let me remove this cursor. We get the cursor. Then first we want to create this output first. So first we created the connection from here, this, and then using the connection we create the cursor to execute the query. Then we send this cursor to create the output table, which is we define like the enrich table. Then we get the enrichment value, so we get all of the enrichment information. We just check if length of the reviews is 0, then no reviews are there. Print enrichment of the length goes to the model, is like simple statement. Then results into the list for review id, like going to the each and every review. Try labels is equal to classify review. So once we get the review, we just put it onto the classify review, so it will go to the LLM model and it takes the comment. So we will put this comment into that review, and whatever the result we get, we append this onto the result. Append here review id, labels, label score, all of these which is coming from here, and we'll have exception if anything occurs. Save result, commit, cursor close, connection close. Is that cursor available? Yeah, it's cursor. Okay, cursor close, connection close. So let me just explain you this again quickly. Just return this. So what we do first of all, so first step is to get the connection. So we create the connection with the Snowflake. Then we get the cursor. Again, basics of Python. If you want to work with the databases, you have to create a cursor that executes the query. Then you create the output table. So it goes here. Cursor is here. Creates the table. If it is not existing, creates this table. Creates the schema and creates the table. After that, it will create the output table. It is done. Then it fetches the information of the reviews, and we check the reviews. If it is 0, then we don't do anything else. It starts processing. For each and every review, we get the review id and the comment id from the database. We pass this review to our model. This will get the output. We store all of this information into the list, and at the end we save this cursor and result, and we close the connection. And now we have to close call if underscore underscore name main, and we call the main function. So whenever we run the script, this main function will be called and this will start running. Now one thing that we have to insert here is OpenAI key. This one. Okay, so api.get OpenAI key, and we can put this over here. OpenAI key. And where do you get the OpenAI key? Is by going. Now I don't know if they have the free credits available. If not OpenAI, you can use anything else, but you all you have to do is just go to OpenAI API. You can sign up to the API platform. You can log in. Let me go to login to API platform. I'm already logged in. You can click onto the API keys. I already have the API keys. I don't know if they provide like free credits for that. You can just you have to just click onto the create new secret key. Let me just create my Zomato key. I will disable the key after the project. So uh, right now I'm just showing you. So this is the type of key that you'll get. You just have to paste it here. Once you do, your project will read this key from here. All of the things are done. Let me just try to run this. So I'll go to my terminal. I'll go to cd AI ls and run in my Python 3.10 version enrich py. Just try to execute and see if we get any error. The first is no module name dev, so I have to install .n pip3. This downloading installed. Now if I execute this, let's see what happens. Enriching file review, that means it created the table on top. It is going one by one to enrich the review. So if I go to my Snowflake table and refresh this, it will be on the AI schema. So I'll go into the AI schema. Table is available, review enriched available. I'll just see the data preview right now. Okay, so there's a typo on the script. I keep forgetting this cursor thing. Yeah, it's cursor. I think now it should be good. Let me execute this one more time. Enriching file reviews. Let's see. We make it a little bit big. What is the issue, right? Execute many connection parameter formats requires a mapping. There is some issue around connection formats requires the mapping. I think it is failing onto this this one, which is uh insert statement. I have one insert statement available. Let me just try to put that here so that uh, this generated one we can this is generated by the copilot. So let me just put this here, more cleaner version. uh, Now I'll try if this is an issue. Okay, so this is done. If I go and if I refresh this table, let me preview one more time. Query produce no result. So enrichment was done, but nothing was inserted. So what we'll do, we'll just try to print each and every review first, like classifying this review and see if we are at least getting these information. So review and comment, if this is passing. So classifying this review, it is going. Classifying this review is going. So this is happening, like it is going to the model. And let me print labels also, so that we'll know thus if the model is actually executing this or there's a model error. So we can see here, enriching review file, classifying review, and model data is coming as sentiment label, positive, sentiment score, topic, pricing, key issue, none. So it is actually giving us all of this information. So model is working. There is no other issue. Then it runs one by one, saved this much, and I think issue might be onto the insert side. So let me just run one more time. Is it why it is not coming here? Data preview. There is no data that is getting inserted. That is an issue. Classifying, saved. So it is saying saved, but I feel it is not actually getting inserted for some reason. So data is getting inserted. If I go to my Snowflake and if I just do select star from, place the name on it, and if I do search, you will see review ID, sentiment, which is positive, negative, neutral. Sentiment score is available for each and every review. The topic is about packaging, pricing, some service related. Key issues, some of them are saying too expensive and oily, tasteless food or something like this. The model that we used is this and the date. So our first pipeline is working. Right now, what we just did, simple thing here. Let me get the orange one. This one, right? This is working where we had our reviews, we put it onto the prompt, we put that onto the AI and onto the Snowflake table, and AI enriches all of these things. So it's pretty simple. It first creates the connection, then creates a table, then it fetches the each and every sample. Right now we are just working with the 5 sample. You can actually work with more and more, and after that it classifies the review. We use a GPD model, we add the OpenAI key, we define the role of the system, what it needs to do using the system prompt that we have defined on top, and the role of user, which basically it gives you the comment, it gives you the response. We load it into the JSON, and then one by one we upload this and insert this into the table. So this is the first enrichment pipeline where it uses the AI model, fetches the data from the table and put that onto the this put it onto the Snowflake database. So let's just get finished with the RAG and text to SQL pipeline first, and then we will orchestrate the entire pipeline using Apache Airflow. So we have completed our first step in AI lane, which is LLM enrichment, where we just inserted the review, executed the LLM model on top of it, got the enriched review, and put that onto the this uh, Snowflake table. We can also build the DBT table around it and try to find more insights. But other than that, we will work on the second part, which is this one, RAG pipeline. And again, it is going to be simple. It's not that complicated. It looks complicated from the outside, but when you start working on it, it is also quite simple. So what I'll do, I'll just go to my first. Let me open this, minimize this. Same, open inside the AI folder, click onto the new file and give the name as rag.py. You can give rag chat. This is a chat application. So chat.py or chat. Now, again, we'll import some of the things such as import OS, import numpy as np, import pandas as pd, import Streamlit here because we'll be using Streamlit as a chat application. Same Snowflake connector. So Snowflake connector, from OpenAI, import OpenAI, from load environment, all of the environment variables, load.n. Okay, this is done. Uh, we'll start with, first of all, you can just do st dot title, which is like a Streamlit title. You can just write chat with your Zomato reviews, something like this. This will be visible when we run our Streamlit. And st dot caption, uh, something like uh, searching, will have like number of reviews, num reviews, will get like reviews answering with, we'll have a chat model, right? We'll use that. We'll write these two things on top. So what do we have? We have first is mm, embedding model. So first we have to define embed model. We understood in our rack pipeline that in order to have a chat application, whatever the data that we put onto our AI LLM, first we have to embed the data. So I will show you the working of embedding. Once we embed the data, how does it look? Then we have our chat model. Chat model is same chat GPT. Number of reviews will put as 500 for now, and top K, which is like top reviews to load, will put the cache file also, so that instead of review embedding, which is our cache package. So instead of asking AI again and again if the information is available inside our cache file, so that we don't hit and waste token again and again for the same question. Once these things are done, we define our client as OpenAI API key. This is available in OS, and we start doing the different things that we want to do one by one. So first of all, in order to talk to the LLM, we need to load our reviews. So, and to load the reviews, let me see if you guys can see it properly. Yes. Uh, yeah. To load the reviews, we have to like have it like review df is equal to load reviews. Now we'll create this function on top, def load reviews, and in this load reviews, we want to connect with the Snowflake account, and we want to load all of our reviews that are available. On top, we have to write this st cache cache data. uh, when you write this, so st cache data, so this is a function available on Streamlit. So whenever you run your AI model, embeddings and everything, the embedding that we have defined here, it will get stored. So instead of going to the AI model and calling it again and again, that will cost a lot of money. We always want to use our cache data. If it is not available, then we go there. So if os dot path dot exists, the cache file, if it exists, the data already exists, then we directly do the pd.read parquet and cache file. If it is not, if it doesn't exist, then df is equal to, you will do something like read reviews from Snowflake, and we want to write this function on top, def read reviews from Snowflake. Let me just stop this. So if we don't have the data available in a cache, we have to read the data from the Snowflake, and we have to define this now, which is first we have to do the connection. Let me do, where is that Copilot connection? Same user password account. We have to define, let's say, account on top. It's quite easier to understand. Password. Then a warehouse database schema. Role, I think we can add a role. I think it's fine. So once you create the connection, you have to write a query is equal to f string. Inside this, I'll write select review ID, city, rating, comment from Zomato dot staging dot stg underscore reviews, sample, and what are the sample size we have available, number of reviews, rows. So this table, we have it available onto our Snowflake. This is our staging table. If you go to the staging schema, this has if you do the data preview, you will see we have created our staging customer ID, restaurant ID, ratings, comments. You have city available, review date available. So based on the city also, we can ask a lot of questions over here. Okay, then this is a query. We just fetch the data, the sample data from here, and then we execute this query like df data frame is equal to connection dot cursor dot execute query fetch into panda. So we have this, then we close the connection, and we will return the df, or we'll just do df dot columns. Every column should be into the lower case so that it is consistent across everything. And then we have the return df. So once we have the df available here, we do df embedding. Let me just remove this. Embedding is equal to embed function, where we add our data frame, embed function into data frame, and do df to parquet cache file and return df. So what we just did, we have to write this embed function here, def embed, and whatever the text that we'll get now. But we will call, we'll get the review from the Snowflake. We will put this onto a data frame, whatever the embedding, we want to convert all of the text into the embedding format. So we will convert that, and then we will cache that file onto our this, which is, and then we will cache this file to the local, which is a review embedding that we have created. So it will store all of the embedding information. Now we have to write this embedding function. It is pretty simple. You just have to call OpenAI API again. So response is equal to client.embedding.create. You have your embedding model available, and then input is equal to text that we get from this, and then you return item. You can just print embed for now, right? This response for now, just to see how it looks. So let me just try to run this once. Load these reviews. Okay, let's just try to run this, if we and see what do we get, and errors, if we get any error. So I'll just do same cd AI. Let me go into the AI, and here I'll run Python 3.10 rack chat py. There's an issue. Do you mean streamlit cache date? Do you mean data? I think, yeah, I added date. Our cache data. Yeah. Let me run one more time. Streamlit is running. There's some warning, which is fine. Main thread. Yo, okay. Let me just stop this. So you see all of these numbers, all of these random numbers, these are the embedding numbers that I told you, that we convert our text data into embedding. All of these are the embedding numbers. So what we just did, I just wanted to show you what embedding actually looks like. So when you load the review, this will go to the Snowflake, this will fetch all of the review, this will put it onto the data frame, and then it will come here. Then it will call this embedding function, pass all of the text, and convert this into embedding. And the response that we got is this numbers. So machine, like, this is an OpenAI embedding model. So this convert our text into the embedding. And now we can do the next thing. Like, instead of this response, we can just return each item embedding from the response data, and this will come here into the data frame, and this will be returned to the cache file here. So this one part is done, where we are able to load reviews and convert that into the embedding. Now what we have to do, again, we are building a chat system where we are where we can write query into our text format, and then get the information from there. So we have to do something like question, right? And do st dot text input. This is the streamlit function, where we have asked about your chat reviews, uh, and then we can have a placeholder also added. Placeholder example, what are the most common complaints about the delivery, something like that. And let me close this. This is comma here, I think. Yeah. So this is a question. Now if there are question, then if question, we have to get first top reviews is equal to find similar reviews, and we send our question and reviews df that we got, and ask, this is our question, and answer is equal to ask LLM the question and top reviews. So two functions that we have to define: find similar reviews. First, like when we are building a chat application using a Streamlit, I forgot to explain what Streamlit is. Wait, we are just talking about Streamlit, but Streamlit, might of you know, but this is an open source Python framework for data scientists, AI engineers to build interactive data apps, right? So if you want to build something like a chat application, visualize something in interactive way, you can just write a simple Python code, and this will give a interactive web application. So you can work it on the browser level. So for example, if you do like st.write, it will start writing. If you just write, run 15 window function or slider forecast or whatever visualization that you want to do, it will do it automatically. You don't have to do anything by yourself. This is an open source and also integrated inside the Snowflake only. This I forgot to explain you when we got started. So we are building our entire chart application using a Streamlit itself. So we have to define two functions, which is our this find similarity and ask LLM. So find similarity, which is we'll just do here. Uh, def find similarity. It needs questions, and you have your df, and here question vector is equal to, first we get our embedding, like basically first question, we also have to embed that. Again, understand this, machine does not understand the text, machine only understands the embedding. So when we loaded our reviews, we embedded that data and put that into the df embedding. Now when we got the questions, we also have to put these questions into first embedding model, and then for review vector we check into df embedding, or the df embedding that we had, whatever the df embedding, let me just remove this. Okay, df embedding which we pass, which is the review df, right? This review df is an embedding model. This goes here, and then we have to call a cosine similarity function. So score, we have to check if it is similar or not. If it is similar, then we return something. If it is not, then we do something else. So score dot append, then you do cosine similarity, where you pass your question vector and the review vector. So question and the review both goes here, and we have to define this cosine similarity on top def, and this has like vector a, vector b, which this is the formula again of the cosine similarity. You can just search online, this is a formula available, np dot 2 of the vector, then there's like some mathematical formula. We don't want to go in detail right now about that, but this formula just returns the similarity between two vectors. If this score, I think we have to define the scores here. Yeah, scores, and then df is equal to df, let me just copy this df, and df score as scores return top score from this, whatever the similarity that we get. Once you find the top reviews, you send this top reviews from here and your questions. So first you check the similarity between your reviews and the question that the person has asked. Once that similarity matches, you get the top 5 matches from the reviews, and then you pass the top reviews and question to ask LLM, which is here def ask LLM. We have the questions and the top reviews available, and here wait, and here we will have context is equal to let me just put the empty here. So for dash and rows, each and every reviews will go one by one. We have to set the context for all of the information that we are providing. It looks something like this. Let me just write it. Plus is equal to f all of the row comment, no, not the row. We have city, after that comma, we have row as rating stars and the comment. Again, when we are feeding this information to AI model, we have to give it the system role and the user role. So we are just trying to create a complete prompt here. So we'll just give system prompt is equal to something like answer only using the customer reviews provided, be concise and be concise. If the reviews don't cover it, say so, something like this. And then we create a complete user prompt as user prompt is equal to f question is questions and review context. So we have the question, and then we give the reviews as a context to the model, and then we actually do the last thing that we did, client. Then we select our uh, model is equal to our chat model. Temperature is this. We'll just put 0.2. Message, the system is our system prompt that we have defined here. This is prompt, this system prompt here, and user prompt that we give, and the response we return response as message content. Let me explain you one more time what we just did so that you have a clarity. So first we load the review. This will go to load review, where it will check the cache. If it doesn't exist, then it will read the review from the Snowflake, where we just do the simple query and return the data frame. Then it goes to the embedding models. This will return all of the embedding that we saw, and this will put it onto the cache file. That is all will come here into the review df, which is the embedding. Then we have the question available. Whatever the question user asks, we find the similar reviews. So first we also embed the question, then we find the cosine similarity between the questions, and from the all of the similarity we just get the top 5 similarities and get it the top reviews. Then we put both question and the top review. These both are again embeddings only. Then we put them onto the ask LLM, and this ask LLM where we generate the prompt, specific prompt, the system prompt and the user prompt. In the user prompt we put our question that user asked, and all of the reviews information that we put inside one single chat, we supply it to the LLM model, and LLM model will give us the final output. So it will look something like this: st dot let me do markdown and answer, uh, answer something like this, and st dot write answer, and then something like with st dot expander uh, reviews used to build this answer. We want to see what are the different reviews we used. So st dot data frame top reviews, city rating comments. We don't need a score here. It's fine. Top reviews that we used and reset index, or you can just do uh, hide index is equal to true. We don't want to see the index, so this will also print the data frame. This is the entire thing that we did. What I'll do, I'll just run it and see if we have any issue here. So I'll clear this and I'll run again rack chat. It is running. Main thread, stop the context. I think it should open this application onto the browser. So in order to run this onto the Streamlit, we have to run this command Streamlit run and rackchat.py. So let me just run this. This will open a Streamlit server onto the browser, and this is where we can start talking to our AI. So chat with your Zomato reviews, search something like 500 reviews answer. So uh, what are the top complaints for today, something like this. Again, this will go in the backend, it will run the entire code, and top complaints are about the quality dropping, being overpriced, and these are the top complaints. Pretty amazing, right? We were able to uh, write a simple question and AI is able to give us the answer. Best reviews from top 5 companies, not companies, from city. Okay, these are the best reviews, like 5 reviews totally worth every rupee from this, then Hyderabad, Chennai, Pune. Then again, whatever the data that we have onto Snowflake available. Uh, fetch me, fetch me top uh, worst comment or review. Worst comments from Hyderabad, the delivery partner was rude, 1 star. So Pune is like rating 2, then Pune, Kurur, and all of these different things. So this is a simple chat application that knows about my Zomato reviews, and I can ask a different questions and it just gives me the answer. So pretty amazing. Like this should blow your mind. So if you reach to this section, if you completed this, right, this blew my mind in the comment section, because I want to know if you also reach to this section, if you are able to do this. So simple, it is running onto the server, and let me again explain the code. Every foundation model, everything that we learned in this foundation, right? That is the reason I included this as a core foundation concept when we started the video, because I wanted you to understand what we are doing. The cosine similarity distance, right? It is just doing the cosine similarity here that we just did. Either you can put it onto vector search or you can chat about it. So we are chatting about that particular thing. Um we built this entire RAG application that we learned over here, and now based on that, it is doing everything, right? Simple. Again, you can generate this entire code with AI. We don't have to write it, but I wrote it just so that you can learn how the entire thing functions, and this is the reason I explained every single thing one by one. So same thing, I'll explain you one by one what is going on. First of all, we load all of the reviews that comes from the Snowflake account over here. We put that onto the embedding. All of the reviews we have, we printed that embedding on the top. If you remember, I don't know if I can see it, I don't think so. It went away, but we can print all of the embedding one by one, and then based on that, we convert our questions that is asked by user into embedding. We try to match that embedding, what are the similarities that we have, that cluster, it goes to that particular cluster over here, right? It retrieves. First we do the embedding, right? Then you do the retrieval, which is like, oh, whatever the question it asks, it goes to the embedding model, it does the vector search, finds the similarity, whatever the top matching, we return it, and then we provide that context to the LLM chat, and then LLM chat will give us the answer. This is RAG in simple execution way. Nothing complicated. It's not that complicated. All you have to use the right function and you will get the right output. So this part, okay, this part is done. This is also done. So we have completed these two things. Now only the last one is remaining, which is text to SQL, and this is also somewhat similar that what we have done in this RAG thing. So I hope you're enjoying this video. It's been very long, so it's been a very long journey to reach here, and we are almost there. We just need to finish two things: text to SQL, and the last thing, which is orchestrating the entire pipeline. So we'll now do that. So we have finished our two layers of LLM enrichment and RAG. Now let's start working on a text to SQL. Let me open. So we will again use the Streamlit for this. This is more of a converting our text into SQL and then executing that query. So let me just start a new file and we'll give the name as text to SQL, text to SQL dot py, and we'll again start the same way. Let me just import some of the functions from the last script only. So we'll import them here. These are the same function. We will have like model as GPT same mini. There are some words that we want to, like when we convert like text to SQL, we want to have a control of, we want to add a guardrails around what we are doing, and so we want to add a forbidden word. So forbidden words is equal to drop. We have like delete, truncate, alter, update, update, insert. I think we can have no insert, drop, delete, truncate, truncate. We have insert, alter, create, replace, grant, revoke. All of these things we want to forbidden it. And some of the example questions we also want to add. Example questions. Let's say top 10 cities by GMB. Then which cuisine has the most orders? Then average delivery time by city was first, and this is average, and this is cancel rate by payment method, something like this. We'll create our, we will create our client, and mm, we can just start writing. We can create our client and we can just start thinking about our execution. So first, streamlead dot title, chat with your Zomato data, and then we have caption same, uh if if asked in English, our will model writes the SQL Snowflake run set, something simple that we have caption. Again, this is not some query, this is just a simple caption. Now let me see what do we need to do. We have to define two things. One, we have to define the schema where all of our tables are available, and we have to define this system prompt that is important. So schema is basically where all of our data are actually stored. So we can just write something. Let me just get the schema here because this is quite big. So I'll just copy it and I'll put it here. So this is our schema. So basically, we just try to add all of the information that are available onto our Snowflake. So for example, we want to start answering the questions from our Marts schema, this schema. So we have like this fact order items. So over here, like we have like fact orders, and we'll all of the column we have available. These are the columns we have available. We have just written them here into the fact orders, the same dim restaurant, dim customer, mart daily revenue, restaurant performance. We just added some of the information here so that schema information is given to the our model so that it can write a proper query based on the columns it is available. So this is the first part. We have it. Wait, yeah, this is the first part that we have available. Now we want to. Okay. So schema is available. After that, we also schema is available. Also, we need to add a system prompt. So I'll just add a system prompt like this. The system prompt is basically you are a Snowflake SQL expert. Write one select query that answers the question. Rule is only select queries. You never modify it. Use the bare table names like this instead of providing the entire thing. You add a limit and apply the simple into the SQL query file. So and then we attach the schema that is we have here when we actually pass it to the model. The simple this is like the simple, we have our schema available, we have the system prompt that we want to put it, and then we'll just write def get connection, and we'll create the connection that we have created till now. Same, we will cache this connection, cache uh, resource, this one, and then we have okay, account information available, username, password, warehouse, database, schema for this one we need Marts one. In our environment file you will see we have the schema as AI. So right now we'll just hard code here, and role is equal to, I'll give dbt role. It has all of the things. Warehouse is Zomato warehouse, database is Zomato database, everything else is fine. Once we have the connection, we will need a different function. One function to handle the questions from the user, one function to execute the query. So first we will just create a function to generate SQL, and whatever the questions user ask, we will put it here, and then based on that we will generate using API. So response is equal to client dot same function that we are using. We have model is equal to model, uh, model, comma, we have temp temperature is equal to 0. uh, Client is not defined, we have defined the client on top. Okay, yeah, we have to define the client also. Let me just define it right now itself before I forget. So client is equal to OpenAI. Okay, so client is defined here that we can use. After that, we have a response format, that is our type JSON uh, object, and then we have messages. Same, our system is a system prompt and the content is a question. So basically we pass the question and the system prompt that we have done. AI will answer this, and we get the answer is equal to response in this. SQL is equal to we'll just do join JSON loads. So we have told in our system prompt to return our output into the SQL and the query as here. So AI will give us the do we have JSON imported? Let me import JSON. Import JSON, right? Now JSON load SQL. So this will give us the raw SQL query like select star from Zomato and the table name. What we want to do is we want to replace the Zomato name with the actual schema name. So SQL is equal to SQL dot replace Zomato dot Marts dot and comma empty value to replace normal Zomato dot and return SQL dot strip and R strip to a semicolon. So again, we'll look at the example of this when we execute so that it will get much clear why we did this. Other than that, what we need to do, we need to check if the SQL query that was written, if it is actually safe or it generated some forbidden word. So is safe SQL query inside this. Uh, First, we do s lowered is equal to SQL dot lower. First, we convert them into the all lowercase. If not, lower starts with select. So any query that does not starts with select and not lower starts with, that means the query is wrong. So right, we only need with or select query, any insert, update, truncate, whatever the query that client generates, we don't want that. And for word in forbidden words, all of this for so for word in forbidden words, so all of the forbidden words we have defined on the top. Okay, any word, if word is in this lowered one, then we return false, else we return true. Simple, we are just checking if the SQL query that was generated is correct or not. And then one is to run the query, so the query that was executed, so QU query SQL. So first you get the connection, then you get the cursor, and then you do all of this. Instead of just, we can just write it in the simple line, return cursor dot execute dot SQL fetch pandas all. So this will return the entire data from the table. And then let me just put client on top here. I think we have already defined the client. It was at the bottom, so it is here. After this, the simple Streamlit application. So what we will do, we'll start this with Streamlit dot sidebar. On the sidebar, we want to display some of the example questions that we have. So st dot header example questions. For every questions in Streamlit, uh, we'll just do st dot markdown f. I think this is fine. Yeah, we'll just display the example questions. Then we'll ask questions from users. A question is equal to enter your question here, and example value we have given. This is more of a placeholder, or we can just write something like placeholder here only. Placeholder is equal to example top 10, let's say restaurant by something like revenue in Bangalore. Okay, this is fine. So this is just a text input we are getting from the user. The sidebar is created. Now, if question is there, then we pass this question to generate underscore SQL question. After that, so this will go to generate SQL here. This will send that the system prompt and our questions, convert that into the SQL file, and will return this will return the SQL code. So st.code will just display the SQL code that was generated. And after that, if not is safe, basically if the SQL is not proper, we just display the error that generates a SQL is not safe, because if user is trying to insert something, delete something, something like that. Else, I'll just say try df is equal to run query. So we will run our query that was generated from LLM, and we pass it to the Snowflake because we already have a connection. So in run query, you will see it connects to Snowflake, it executes the entire query, and then it returns the data frame. So we'll just do st dot success on the Streamlit, will display a length of df. So these many rows were returned, and here st dot data frame, we have df hide index true view data frame, and then except we have error running the query, and I think this is fine. So So I think this is fine. Let me just try to run this onto the terminal. Let's see what do we get. Not here. Yeah, so there's a Streamlit application running. I'll just stop this and I'll do, instead of rack chat, we will run text to SQL. I think there's some error. This is showing red on top. So I think I have some issue here. This is fine. There is error somewhere. Not able to find it. Model is equal to GPT-4. This is fine. Hmm, F is fine here. System prompt is fine. Let me see. Yeah, this is fine. Let me just try to run it. If there are any issues, it will just throw it. Text-to-SQL. I'll execute this. Streamlit run. Okay, it executed. On line number 64. On line number 64, schema is equal to Marts. Okay, let me see. Line number 64. Okay, there is no comma here. All right, now yeah, I think I was missing the comma. Let me restart the server. Let's see. Okay, so I have the Streamlit application. So I have the Streamlit application here that is running chat with your Zomato data. I'll just copy this question and let me paste this and execute this. This will again go back, run everything. So the query got generated. Error, Mart daily revenue does not exist or authorized. So Mart daily city revenue. Do we have Mart daily city revenue? Let me check once here. Mart daily city REVENUNE. Mart daily city REVENUE. I think yeah. I had a typo here somewhere. So what I'll do, I'll just edit the definition. Uh, hmm. I'll just edit. So I have the typo here. So what I'll do, I'll just update that over here into this. Okay, there's like NUNE. Let me just stop the server and start one more time. And again, I'll run the same query. Top 10 city, let me clear the cache and I'll run top 10 GMV. So it will execute the entire thing. It is running the connection. 10 row returns. So what we just did, we just asked like top 10 cities by GMV. It created the SQL query based on the data that we added. And then we got the output. Pretty amazing, right? You can just ask simple text. For example, this question, which cuisine has the most order? I think there's a typo here, but again, AI will figure it out. Let's see. See, again, the cuisine trends does not exist. So we might not have a Mart cuisine trends. Cuisine trends is available here. Do we have the table available? So Mart, we don't have the information about the cuisine table. So that is the reason. Let me just, we don't need this. What do we have? Mart delivery city. We don't have this cuisine one. Let me just stop this, run it again. I think we can run query about average delivery time by the city and see what happens. And hopefully this works. Yeah, 100 row returns. And this is like the, again, average delivery time city worst one. So these are the worst city that is available. And I'm able to get this just by writing SQL. You can also, like, let me just stop this. And you can also add one more version on top of it if you want. What you can do is you can adjust below at here. Uh, you can add this code data frame, and if length of df dot columns is equal to 2, if there are two columns, and pd dot api dot type is numeric. Let me just paste it here. Oh, that's is easier. Uh, Basically, this code will check if the length of column is equal to 2. It means there are two columns, and one of the second column is the numeric type. So it will create a bar chart where it will plot on the x-axis, which is the non-numeric, and the numeric one will go onto the y-axis. If I save this, if I run the Streamlit again, what it will do when you run anything, for example, and when you ask questions about average delivery time by the worst city, you will see the this. Wait, it did not. I think that we have to clear the cache. I think. Let me clear the cache. Clear cache. Let's see if it creates visualization. P20 is invalid. Let's try this. What do we get? Okay. So it will do something like this. So it will do something like this. It will also create a chart. Let me try writing this. Row returned. Right now, I think for this it is not creating uh top 5 only. Let's see. I'll get top 5. For this, for some reason, it is not creating a table. But yeah, you get the overall idea. Let me try something like top 10 cities again by GMV. And yeah, I think this makes much more sense. So select city GMV, merchandise value from the revenue, and it actually plots the entire chart about whatever we have. And this is more interactive, and this is the power of Streamlit. So this is the overall this is the overall flow. Let me just explain one more time what we just did. Pretty simple. Here we start the Streamlit, which is like chat with your Zomato data. So when you say chat with your Zomato data and the caption, then we add a simple input. There's a sidebar we added, which is with all of the questions that we have. Then the simple input box where you enter your question here. Then if we generate the question, so whenever we write any question here, we pass this to generate SQL. This goes here, generate SQL, it goes into the model. We provide the system prompt, which is we want to convert our text into SQL query and the question the user actually gave. This will convert our SQL into the query. And once we get that, we check if this SQL is safe, if it is like has some update insert value, we don't consider it. Else, we run the query, we get the row returned, we check if this is like the simple again running the query. Once we get the SQL query, we just want to run it on the database and retrieve the result and print it. So this is the entire flow. So this is our this model. Final one. Let me just put it here. So this is our third, like AI lane is complete. LLM enrichment, where we're able to see the positive and negatives of the our reviews. RAG pipeline we did was pretty amazing. You can just type and get all of the data. And text to SQL, we are able to, again, it's not a sort of RAG, it's more of a chatbot type where you can just chat with your data warehouse and get, and you can again improve a lot this. Right now we have just added like some tables, but you can add, try to add more and more tables, add more and more context about your schema, like what it is, what it is not. If you add more information, you will get that type of output available and given to you. And then we have the Apache Airflow that is left, that we just want to add enrichment part, and I think build the entire data mart. So once that is done, we are good to go. So let me just do this, and I think it is pretty simple. Let me close this AI. Let me open that Zomato batch. This is our Airflow, and in Airflow we just have to add two things. Again, two operators. First one is I'll just do dbt build AI is equal to bash operator, and I'll just add, no, before the build AI I'll just add enrich reviews is equal to bash operator, enrich review, and the bash command is, it's not this, f python slash, yeah, opt airflow enrich reviews, and we close this, and at the end you do dbt build AI is equal to bash operator, task id is equal to dbt build AI, comma, bash command is equal to f dbt build dash dash select tag as AI. I'll explain this, and project dir as per above, which is dbt underscore project, and the same profile dir. We want to get this, okay, and we add both of these after this. This is added and this is added here. So on Airflow we updated this, which is enrichment of our review and executing our entire AI pipeline also. So we have to add this. What does that mean is going to Zomato, and over here go to models, uh staging, and we add a new file as underscore AI dot sources dot yaml. You remember we added this table onto our thing in the raw only. It's not here, I think it's in the staging. Let me open. We have added, we have added this, okay, so we have added this table onto review enriched, and we want to also define that particular information in our dbt also. So we'll just do this simple thing, where we will do AI sources, and the name is AI, schema is AI, Zomato, table name is review enrich that we have added, and everything else is just a description. And on to the marts, we will add a new mart table, new file, which is called as a mart review insights.sql, okay, and this will be the final query about select. You can do, you can just write config on top, config tags is equal to AI. We add this on top. I'll explain you about this. Select from source AI review enriched as E, inner join will join all of the reviews. So ref stg s single quote stg underscore reviews are using review id, and then we'll select the column as rr.city, e dot topic, comma e dot sentiment, underscore label count star, uh then round and get the average e dot sentiment score and round up to 3. These are as reviews. This is as average sentiment score. So based on a different city, topic, and sentiment label, we're just trying to get the average review, sentiment score, average, and the rating and flagged issue. So let me just add that here. Just add comma, count, group by 1, 2, and 3 first, and everything else is fine. Now this tag about this, when we run a dbt command and when we want to run a specific file only, let's say we have tagged this particular file as AI. So in our Airflow, if you see into the tag folder, we just on select, we selected based on a tag over here. Here we have excluded a tag, so when this runs, it does not run the AI files, and when this runs, it will run the only the AI files. So what will happen first, it will load the raw data, run the entire dbt without the tag AI, then it will execute the enrich python, and then it will select the tag one, and this will run the entire thing. So what I'll do, I'll just go, let me just stop this, let me clear this, and here first let me run docker compose up and get my Airflow running. Okay, it is starting. Let's wait. We can go to local 8080. We have our this. It is already it's already started running. I'll go to DAG. I'll check the running logs and see what failed, what succeeded. So right now this is running. This one. So first one is succeeded. We already saw yesterday. Build core is running. I think this will also be successful because we were able to do that. Enrich review will also run most likely because I don't think we should face any issue here. If we face, we'll just try to see that. But dbt is running, it is fine. Now enrich review started running. Let's see. It is running. Let's see. Okay, it is classifying all of this. So this is also successful. And dbt with AI. This might turn into error maybe if there are any issues. This is running. Let's see if it is successful. Yeah, it is success. So our entire DAG ran successfully. That means now we can automate this entire part. Just schedule the DAG and it will run every day. We'll load the raw data up, then it will build the entire DBT, then it will enrich the review and build the final AI. So we will have our if I go and refresh onto the Marts, you will have your review insights also available here, that you can see it and understand that based on the different city, what is the issue, if it is positive, negative, and then you can gain more insights about this. So this is an entire pipeline completed. This entire pipeline is completed. This entire pipeline is completed, and sort of we have completed this entire project. Wait, this entire project is complete. Now don't go anywhere. We want to clean this entire everything that we have done. If you want to clean it, you can do it, and I'll explain you how to do that. Other than that, we have completed this entire pipeline end to end. What are the next steps from here? Next step is, right now we are loading this data again and again, but you can also, for the copy command, you can also add some statement just to load the newly added data and move the data that is already loaded. So you can instead of, right now we are just loading one data again and again and rewriting entire pipeline. But the best practice in the real world, if you want to do, you can just simply move your data or just check if this data is already loaded before loading that data, so that you have the incremental data loaded and it only runs onto the newly added data. So that is the one improvement you can do. But on the other hand, we have our entire pipeline running. We To summarize, we had our initial data onto Zomato, we loaded that onto the Amazon S3. uh, then we created the connection from S3 to Amazon AWS bucket, uh, and then loaded our first raw data, used the DBT to build the staging and the Marts, and Streamlit to do the visualization using AI. After that, we did some orchestration to, for the uploading and the building part of the DBT, and then we went with the AI lane. We understood the core concept of AI, what are the different things we need to know to execute the project, LLM enrichment, RAG, and text to SQL. We were able to do all three things, and then we built the entire orchestration. So this is like full complete AI data engineering project that we completed. Now if you want to improve this project, you can of course do it. You can add more data into it, you can add some API data if you want. You can add your own Zomato data from your application. If you can export it, you can also attach here. So there are a lot of different applications if you want to make this a real world, but I just gave you a good foundation understanding of how to build complete end-to-end AI pipeline. Now once you've done this, and if you have completed this project, let me know in the comments that I have completed this entire project. And once you do that, now we can start cleaning up. What you all you need to do, like this stop let me just stop the airflow, let me close some of the files here. Let me turn off my API key that I created. So I'll just revoke this key so that it does not get leak. Even for my Snowflake, I will update the password afterwards, once I stop the recording. But if you want to clean it up, again, most likely on the Snowflake, you will not get any charge, so you can keep it as it is. If you want, you can delete all of these tables. On your local, you don't have to do anything because most of the things we have done it on local. On AWS, you can remove the on AWS you can remove the policies that we created in S3 bucket if you want. You won't get charged for that if you keep it, but if you want to clean it up the entire project, you can do that right now. That is the only thing we need to do, and everything else is available on local, so you can always use that. I hope you learned something new, and I hope you found this video valuable. If you are someone who is interested in upskilling in data engineering and want to master data engineering and become a job ready data engineer, we have a complete platform available. This is not just a course, this is a complete platform to master data engineering. One of the issue as a data engineer we face is that we don't know what are the different skill set we need to work on. So that is the reason we have built this complete skill track. So you can come here, you can first create your plan, like you can select your different goals that you have as a data engineer. Once you do that, it will ask you for some assessment. So you take the assessment, and then based on the assessment, the right and wrong answers that you give, it will generate a complete roadmap for you, which is something like this. So you can start working on a different skill set. This is one thing. On top of that, we don't have only videos, we have designed our curriculum in such a way that you learn from the video. You also have like visualization, like you also have the articles that you can deep dive into it. You have the exercises, you have the quizzes to validate your knowledge. And on top of that, if you go to, let's say, if you want to learn Python, you will have your Python labs on the right side. You can like read the article and start executing on the side. And as you complete the videos and the courses, your skill track will also keep improving around your profile. So you will also know that, okay, my Python skill track is improving. We also have 20 plus projects available across like the one project that you did. We also have like different types of projects and use cases available. We have different career tracks, like if you want to become a data engineer, data analyst, or analytics engineer. We also have a different skill track available. So if you want to master DBT on Snowflake, cloud engineering, and all sorts of things, main on top of that, we have coding platform like Lead Code for data engineers. So if you want to prepare for an interview, you can come here and write your code into Python, PySpark, DBT, Scala. We have everything available, so that this will help you to prepare for the interview. We have data modeling playground. We are going to add a lot of things. We also have a resume review. We have companies based guide. So everything you need as a data engineer to master, not just a data engineer, everything you need to master your data and AI skill we are going to add here. This is the only platform that can help you to go from zero to job ready data engineer. So this was everything for this video. If you are interested, you can enroll to the Data Vidya. You can just go to datavidya.com. You'll find most of the information, and I'll see you in the next video. Thank you.